Okay.
Nice.
So my presentation today is continuation of previous research I did. The first related paper was the superluminous vacuum, and this here is a more technical presentation of the original of this idea. The central idea of this research is that the vacuum is intrinsically superluminal energy, and this is very important. If you want to make a theory of everything, can you, Christopher, can you make me to get the full screen, to have the full screen in the presentation?
Sorry, I was on mute. Do you want to present, or do you want to?
No, I don't want to present in the beginning. I say a few words, and then but yeah. So thank you very much. So the problem is that we want to unify gravity with other known quantum forces. In some way, we want to quantify to join together general relativity, which is one of our best theories, macroscopic theory of Graviton spacetime, with quantum field theory, which is the best theory we have, the standard model, the best theory we have about microscopic distances, particles, actually, and fields, and quantum fields. I argue in my research that this will never be happen if we not resolve first the elephant in the room. And the elephant of the room is a part of matter and light is the vacuum. General relativity addresses this by effectively describing space like the vacuum as a sheet, and all the curvature of the vacuum, which is affected by mass, is the curvature of space-time. But actually, general relativity never dives in, because Einstein talks about the fabric of space-time. But the theory does not bother what is essentially this fabric. What is this fabric? What is this kind of material? What is it? And I'm not referring only to the old ether theories. And now it's since we say that this fabric of space-time is our background, if we don't resolve this matter, we will not continue. We will not have a theory of everything. And that's actually a theory of quantum gravity. It's the same thing, because quantum gravity is essentially wants also to unite the macroscopic level all the forces, including gravity. Yes. So now, what the problem is? General relativity. So we have our best two theories are general relativity, which is a classical macroscopic theory, and then they have quantum field theory, which describes the standard model of particles, and which is a microscopic theory. And by definition, these two are incompatible. It's very difficult, because you have a macroscopic theory, and then you have to prove from the quantum field theory that you get emergent theory from the quantum field theory, the general relativity theory, and that's a very hard task. And so when we go now to quantum field theory has the ultraviolet divergence problem. So that actually says that if you go to very small distances, close to the blank sides, then the energy diverges to infinity. And that's not just something we did a wrong assumption. That's what actually the maths show us. My argument is when we find the ultraviolet divergence of the vacuum, so you go smaller and smaller distance close to the blank length, and then the energy explodes. And what we do, we are scared and run away. We run away from the other direction. My proposition is that we should not run away. Maybe the maths are actually showing what was all this time in front of our face. ultraviolet interventions means that the energy goes very large. Yeah, maybe we should really this take in a serious consideration and not just scare away and run away and say no, that's a problem because the speed of causality is violated, the speed of light, and we should have a change of attitude and take this matter, this finding, this mathematical finding, very seriously. So my argument is that the vacuum, you have three big players in the universe. You have matter, you have light, which are luminal and subluminal energies, and then you have the vacuum. And for some reason, the vacuum, all the calculations in quantum electrodynamics show that the energy becomes infinite. What that does mean? It does means that you get frequencies of vibration larger than the Planck frequency. So essentially, only by this last proposition I did, this means that the vacuum is intrinsically superluminal energy. If you exceed the Planck frequency, by definition, this means superluminal energy. And maybe that's why there is the reason we detect practically the vacuum as nothing. If something vibrates, has such an energy, and it's out of phase from your space-time luxons energy. Luxons is another name for photons. It's not necessarily means that it will destroy you. It's just an energy which is much, much larger than yours, and you cannot observe it. It's out of phase with you. It cannot interact with you directly. So what the quantum field theory did is you have the vacuum background, and they say when you go deeper and deeper inside this background, the energy becomes infinite. And what do? They get scared and run the other way around. I propose no, we should really dive in here to see what the vacuum is, because if we don't resolve what the vacuum is, forget about quantum gravity theory and everything. So I actually I've been a bit sad because every paper I studied over the last 3 years or so, going back up to the 60s, describes the vacuum as the background. But what if this background is actually everything? But in order to say that even general relativity, even quantum field theory, starts from the vacuum being the background. So also Kaluza-Klein, the Kaluza-Klein theory, just added another fifth dimension in the theory of Einstein of general relativity. So you don't have a four-dimensional space-time. You have now a five-dimensional space-time. But even the Kaluza-Klein theory theorizes that the vacuum is the background, and it says that these extra dimensions are inside the vacuum. But I now proposing something different. I'm describing a theory that describes the vacuum itself. I describe now the fabric of the space-time. And I say that, but in order to now to continue, you have to accept one thing, one important thing, that the elementary particles we know, the electron, the quark, are not elementary, but they are made out from this vacuum, this superluminal vacuum energy via phase transition, energy phase transition mechanism I will later present. If you are not ready to accept this, that the standard models of elementary particles are not actually elementary particles, but are made from this vacuum flux, from this superluminal energy. So imagine you have you have some kind of vapor in a room, and then you start with your finger making some kind of manifolds, in the vapor. And this vapor manifolds, the vortices and all that stuff, are our particles of the standard model. So you have to accept, if you want to make a theory of everything, that it's all made from one particle. And this particle, I say, it's the one I describe because it has a spin 2, the superluminal vibrating graviton. So I add something that the graviton is actually a very peculiar particle that can be at rest but still vibrates gravitationally, which of course breaks everything we know of, because if it's massless, it must continuously go with the speed of light. But now we're talking about space-time itself. So it's unknown territory, it's unknown physics. And this kind of particle forms a condensate which permeates everything in our universe, including matter and light. So all the matter particles, the massive particles, and also the bosons, the photons, are made from this quantum flux. So this quantum flux now, I say that it's an evaporation product of this graviton. So this graviton integrates all forces. It integrates the electromagnetic force, because if all the particles of the standard models are made from this vacuum flux, and I see that the graviton is evaporating this flux, you know, this kind of vapor energy, then it's essentially that the three forces of the four, the weak force, all the particles from the weak force, the strong force, and the electromagnetic particles are made from this flux. So they are emerging from this particle, from the graviton particle. And in addition, it integrates also gravity itself. So you have one particle which has all the known energies and forces of our observable universe. But the particle itself, this superluminal graviton, cannot be observed directly. Not because it's very small. Yes, of course it's very small. It will be. It's actually its energy. It's bare energy, which is superluminal, is out of phase from our observable luxons space-time universe. So the Kaluza-Klein did fails. The Kaluza-Klein theorem. Kaluza-Klein is a compacted, as I said before, extra dimensions theory. It adds another fifth dimension. And there's a misconception about this. When we say compacted dimensions, we actually mean particles. So if it's another, it introduces another particle. That's all, the fifth dimension. So you have in Planckian sites, you have a cool space-time, which is actually represents a particle. And the particle, the Kaluza-Klein theory says, it's the graviton of spin 2. But the problem is with the Kaluza-Klein is it says that it assumes that there is a vacuum as a background, and inside there is this graviton particle. My theory is totally different. My theory says that the graviton itself makes a condensate is everywhere and is the vacuum. All these gravitons making the sea of gravitons is the vacuum. So the Kaluza-Klein, because it assumes a new particle inside the vacuum, it cannot explain the half-spin particles. It fails because it starts with a spin 2 particle, and it's very hard to evolve a spin 2 particle and make it a spin 1/2 particle. So because what? Because Kaluza-Klein still says that electron is elementary. In my theory, I say no, electron is not elementary. Electron is made up from gravitons, which are in a coherent formation and making up the flux. So each flux line of the graviton charge, we will show later, is actually made is a stream of coherent gravitons. And this this manifold, the total manifold of these gravitons, makes up the electrons. And this is also for all other particles, or all other flux particle manifolds. Of course, a standard model says that all these elemental particles are point dimensionless particles, but please allow me to say that this is not physical, this is not physics. It's very convenient, of course, very convenient. You cannot have something, you say it exists, and then you say it does not exist. It's either the one way or the other way. So if it's not, they say that the elemental particles of the table are not singularities, but they're dimensionless. So there's a contradiction of concepts there. I mean, it's not a singularity, but this is exactly the definition, one of the definitions of the singularity, that it's dimensionless. So yes, it's in my opinion, it's I think we have to very seriously research what this vacuum is at the very microscopic, even Planckian level. Of course, there is no way to verify this. We don't have Planckian physics, experimental Planckian physics at the time, but we have any way to try and theorize for the next generations to come that may be possible do experiments in the Planck scale. So we cannot have a theory of everything in quantum gravity. If we don't do Planckian physics. So my theory is actually in that direction, with the addition that I believe strongly, and my research shows this, that vacuum is intrinsically superluminal energy. So I will now, with this small introduction, I had like to go to the slideshow. I don't know if you have seen part of the already presentation I did with the paper. If you have seen them, so please excuse me if I repeat some things here. But because the session here, the presentation is live and will be on YouTube, I think it's a good thing to repeat this some things and add some also new information regarding the paper in this presentation. Is that okay with you? Okay.
Yes.
So I will go now to I will go to full screen presentation. I believe I remember how you do this. How you do this?
Business is every Saturday.
So I go present. How you do that?
Yeah, presentation. Go to the bottom one. There is something called the present. You see the present button.
Yes. And then it says slides, video file, share screen.
Yeah.
Okay, share screen. Yeah.
Yeah, you have to put end there and then share screen.
Share
it's
screen.
Always.
Don't show the. Okay. So. Yeah. Okay. So can you see me? Guys, can you see the screen?
Yeah, it's coming up. It's coming up. Yes.
It's perfect. Yeah. Go to full screen and then we cannot see ourselves anymore, but we see you in a bigger screen resolution. Not sure what screen version you have.
Yeah, I see my email. Yeah.
Yeah. Okay. So can you see now the PowerPoint?
Only the paper now, not you, Emmanouil. It would be good when you speak that your screen in a mini window or something keeps visible. I think not seeing your mouth would be a deterioration to the understanding. Maybe it's just me.
Yes.
But I would love to have you picture-in-picture or something if the software would allow that.
That's Christopher's job. I don't know to do that.
Yeah, if it's not possible, it's okay. But I think we should have. Best is when we 4 or 5 are on the left side, and you have the big screen, so everybody is in principle visible. Yes, exactly, perfect.
So do you see now the PowerPoint?
Yep.
No.
Yeah.
See the mail.
My email.
Whose mail is it?
No, yeah. I think there's a lack in the communication because now I have opened already my PowerPoint. You don't see the PowerPoint, so it's stuck. It's stuck somewhere.
You have to go to your PowerPoint. See, you put an entire screen, then you go to your PowerPoint, and you have to be there. You have to go to your PowerPoint and be there.
You have multiple virtual screens to handle with, unfortunately, per screen window.
That's the only problem with the entire screen. But I think entire screen gives a complete picture. So but otherwise, you can go to the next.
I stop sharing. I just stop sharing and try again. Present, share screen.
Sharing desktop is better than sharing screen.
Share screen. Yeah. And then entire screen. Yeah. Now got it. Yes, I did something wrong. Share. I think now it's okay.
Yeah. Then you go to your PowerPoint. Yeah, there you go.
That should work, yeah.
and here height. Yeah. Yeah. Are we fine?
Yeah,
Good.
it's great.
Yeah.
It looks
Okay.
great.
So, guys, if you want to mute your microphones, so I can start, if it's okay with you. All right. So thank you all, guys, coming again, because it's August, and maybe you had something to do. It's Saturday, and I'm most honored that you came to this presentation of this research. I will be quick, I promise. So because we have most of the things conceptually we have discussed in the previous of my previous paper, the superluminous vacuum. This one is called the superluminal graviton condensate vacuum. It's a more complete and description of the theory, and also there's some formalism also introduced in the paper. I'm not saying that my theory is a complete theory. Actually, there are a lot of things that are heuristic there, so a lot of guesses. But you see, it's the topic is very difficult. The vacuum, it's actually unknown territory, and it's very difficult not to be heuristic, to make guesses. So it's not a rock solid, rigorous research. I'm not saying that it's this kind of research, but sometimes we have to make a hypothesis and guesses in order to take the science one step closer to the truth. And then come the experimenters and all these people and prove that we're actually wrong or correct. So this is a quantum gravity theory, which is the same thing. Quantum gravity theory and the theory of everything is actually the same. It has the same meaning. By that meaning that we unite all the non-forces. However, my theory here says that this is not possible if we don't know anything about the vacuum, about the dark sector. Because as we will describe later, you see that I suggest that the gravity originates from the dark sector. It has nothing to do with matter. The vacuum itself intrinsically has the vacuum, and the vacuum energy, whenever you have a massive object, a planet in our system, for example, is just a gradient, a more concentrated form of this vacuum energy. So everything is made out of vacuum energy, actually. So the hand here is to find the gold particle in a good sense, and I don't want this to be confused with the Higgs boson, because I don't believe that the Higgs boson was the gold particle actually, since it's the Higgs field is another field in the vacuum background. It doesn't describe the vacuum. It's just one of the many quantum fields which is responsible for giving the mass to the elementary particles, but itself it does not. Nobody says that the Higgs field is the vacuum. So there is actually a fifth dimension. My theory is a Planckian type Kaluza-Klein compacted extra dimension theory, which says that there is a fifth dimension, a new particle. But my opposite to the Kaluza-Klein theory, my theory describes that this particle consists also the vacuum. It's the fabric of spacetime. It forms a condensate which permeates everything, including mass, light, and it's the stuff from which all observable matter and light are made of. So as we see here, this kind of particle makes all normal matter, and also including, we will see later, dark matter and dark energy. And actually, this energy from which the particles are made of the standard model is the 0 point energy of the vacuum. So all the four known forces electromagnetism, the strong force, the weak force, and gravity are integrated, are made from this one single God particle. Inside quotes, God particle. So let's now talk about, because this is very relevant to my theory, a theory of everything and how to discover. So there are actually two main paths. People in the field are trying to make a theory of quantum gravity, which is synonym with a theory of everything. So there are people working the existing two major theories, quantum field theory and general relativity. These are the two best theories we have, and try to work out a way and find from the formalism of these theories a way to unite the two. So this is one way. However, the second way is this here. Constructing, here is spelling error, not constricting, constructing. There are some other researchers who try to make from scratch a new fundamental theory that unites these two theories. And examples of that are the string theories and some other extra dimension theories like the quantum loop theory but there, the quantum loop theory, actually, they say it's not a theory of everything. They just try to explain the structure of the vacuum, but that's all. They don't try to make the connections with quantum gravity and with quantum field theory and general relativity. Okay, so but even these theories are trying always to comply with the quantum field theory and general relativity established theories. For me, this is wrong, in my opinion, because these theories were never made in mind with actually assuming that everything is made, that all these particles are elementary, and they never thought that maybe these particles are not elementary. So if you keep these theories and try always to prove these two theories, eventually you come to a dead end, in my opinion. These theories have some limitations. You can never exceed, and in my opinion, this is very fundamental to exceed these limitations in order to discover new physics. And my problem is the speed of causality, because it restricts our energy span. Both quantum gravity and general quantum field theory stop at the speed limit, of the speed of light. So when the quantum field theorists see that we have ultraviolet divergence, which actually means that you have to go faster than light, if at the microscopic level, in the very small distances, the energy becomes infinite, that means that the departure from luminal energies, you have to go superluminal. And when as soon as they see this, they run away. So, and we will see actually that. But my proposition is no, you should not run away, and should take this matter at face value. Maybe that's exactly what happened. That there is a higher level of energy which is above. It's not actually the background. We will see that the vacuum is not the background energy. It's the sailing actually. It's the higher type of energy which sits above. It's not a background. It may seem like a background. It seems like a background because we see this bubbling, this quantum foam. So imagine you have a pot and you boil some water, and you see only the bubbles, the boiling, and you don't see the high energy. The water is much higher energy density than the vapor. Okay, you see now only the vapor, and you say now that the vapor is the background. No, it's not the background. It's not the background. The higher energy is actually the water inside the pot. So the vacuum energy is the higher energy. So, yes. So, in my opinion, the above methods are not the correct path for constructing a theory of everything and are prone to fail. So what is the correct way to go? A theory that does not obey the limitations set by quantum field theory and general relativity, and instead quantum field theory and general relativity are now emergent theories from this fundamental theory. So you have to construct a theory which is constructed in such a way that the two known theories are emergent from this theory, which is actually seems initially a very hard task, but it's not, in my opinion, because if you find this particle, if you describe this particle which integrates all known forces, then your job fundamentally is finished. Then you have only to do the formalism. But conceptually, that's the basic idea. You have the vacuum. You don't say you have the vacuum, there are particles and another particles and another particle. No, no, no. The vacuum consists of a fundamental particle. It's stable. I say it's the graviton. Yes. From this vacuum energy, all other particles are made. And you have to accept that then, if you do that, you have to accept essentially that the particles of the standard model are not elementary. If you continue saying that these are the particles, and dogmatic say that the particles are these cannot be constructed from another type of particle, then you never will discover, in my opinion, the theory of everything. You put a cutoff in your theory, you say the Planck frequency is the highest frequency, from there we cannot have another energy, we cannot have superluminal energy, so you put barriers in your theory, and that's it. You will never find another. You have to make a leap of faith. So this theory must conclude to a single elementary particle that describes everything in our universe, all matter and energy, including space-time vacuum, and must integrate all four known forces: electromagnetism, all the particles which are connected with electromagnetism, the electron actually, the strong force, yes, which are the quarks and the gluons, and then the particles of the weak force, which are the Z bosons and the W plus and minus bosons, which are actually massive bosons. And don't forget that atoms are also bosons because of integral spin, yeah? So the atoms themselves, although massive, are bosons. And of course, it must integrate quantum gravity. So in that sense, quantum gravity must come from the vacuum. And the mass is emergent of the vacuum energy. It's imagine like a gradient, a localized gradient of vacuum energy, of concentrated vacuum energy. So this particle must be essentially Planckian. So if you go superluminal, you cannot have a massive thing that rotates superluminal. It will shrink. It will shrink. So if you have something in nature, a particle that is going very fast, forget about now space travel and spacecraft and so on. We're talking now about the vacuum. Because in the previous talk, we said to find ways to make a spacecraft go superluminal. But this suggests that you displace the vacuum. You get rid of the vacuum around the spaceship, and you go inside the hyperspace, which is a region where you have lower energy than the 0-point energy of the vacuum. So, but forget now. Now we're talking about the vacuum. So inside the vacuum, of course, the particles, if you want to go superluminal, the size of the particles must shrink as well. So essentially, you go to Planckian length size, and because the Planck length is where the light of speed stops, it's the Planck length is intervened with the speed of light c. So at the Planck frequency, you have actually the speed of light, the fastest you can go, what concerns luxons energy, photons. So if you want to go faster, you have to go lower than one Planck length. So the bare graviton, which is without its stress field, we will see later on, is in our theory is sub-Planck. It's even smaller than one Planck length. That's the way. If you want to go superluminal, you have to go smaller than 1 Planck length. Up to 1 Planck length, still the speed of light, you have half energy and vibrations at the speed of light. But if you want to go faster than the speed of light, you have faster vibrations, you have to go 1 Planck length smaller. Smaller than the 1 Planck length. Yes, that's another thing of my theory, that in my theory there are no dimensionless particles. Nothing is dimensionless. So my part, we'll see the graviton as a closed loop, closed energy loop, which is actually, it has a finite radius. It's not dimensionless. I don't like dimensionless stuff. For me, it's not physics. So okay, I understand it's effective. Dimensionless is a very effective. It's effective description. Very good in translating things, make things easy in mathematics and describing the theory, but it's not physically correct, in my opinion. So this code particle must be essentially Planckian compacted in Euclidean extra dimensions that makes all space-time fabric and the vacuum as a condensate, creates all mass and energy in our universe. However, the bare energy of this particle must be one scale above our luxons for space-time. So you don't, if you want to obey the conservation of energy and also the second law of thermodynamics, essentially the energy that powers our universe, our observer universe, the luxons space universe, must be a higher type of energy. So you must go superluminal in order, or our space-time to exist without breaking the universal laws of conservation of energy and thermodynamics. Therefore, the energy of the God particle must be superluminal, and the particle resides not in our space-time, so it's not Lorentz invariant because it's superluminal, but it resides in the dark sector. So the dark sector is, I call it the dark sector. Some call it dark energy and dark mass, but in my theory, dark sector is whatever we cannot observe because it represents a high energy, which is out of phase of our luxon space-time energy. Yeah. So necessary priorities for this, for my theory, for this theory of everything. All known energy and three forces, electromagnetism, strong force and weak force, and the associated quantum fields originate out of zero-point vacuum energy. So you have this energy, which we can actually measure cosmologically from the expansion of the universe. It's estimated about -9 power of 10 joules per cubic meter. It's a very tiny energy, which is we call the quantum form of virtual particles. And this is energy is what I believe is the energy by which all the other particles are made. This quantum form is used by which all the three forces, the particles, the three force particles, the electromagnetic particles, fermions and bosons, the strong force particles and the weak force particles are made from this vacuum flux of the zero-point energy. Therefore, all particles of the standard models are made from zero-point energy vacuum, or it's called vacuum quantum flux or quantum form, as a coherent stream of virtual particles, which we also know in normal physics terms as electromagnetic flux, similar to what we can see in the field of a magnet. So you have this form, this vapor, and then whenever you have which is the zero-point energy, when we have a coherent alignment of this zero-point energy and the gravitons, which evaporate this energy, then we have the elementary particles of the standard model. So, for example, here, this is the toy model of the electron from my previous publications, and you have here, this is a distortion inside the zero-point vacuum energy, and each line is made out from gravitons, and we will see later how this happens. So here is the graviton, and we have this very energetic ring is the dark energy we call the superluminal rotation energy. This rotates very fast at superluminal speed, and but it evaporates very slowly. It's stable. We'll see that the graviton has an enormous lifespan, almost the same as the universe. The graviton, the universe, the space-time itself, its lifetime in our universe is dictated by the graviton, as we will see later on. So this graviton evaporates. It's some kind of Hawking radiation, but not exactly the same. And this mandel here, this mandel of energy, is what makes these flux lines. So each of these lines here of vacuum flux is actually aligned gravitons, these rings here. And its vapor, its outer mantle here, is the electromagnetic flux. Yes, if we assume that everything is made from this vacuum flux, which is initially incoherent, but whenever it makes out to a coherent form, like this manifold here, then it becomes a particle of elementary particle of the standard model, not of my theory. Yes. Then, so when we have here, for example, a flux line, this single flux line in a magnetic field, for example, is made from gravitons, from these gravitons here, which are coherent aligned like a tube. But we cannot, of course, observe the gravitons. Yes, we observe only the outer layer here, the evaporating here mantle, the halo here, which makes up the flux line. So if you have, by the way, if you have a very tense electromagnetic flux formation, yes, a soliton, for example, made from electromagnetic energy. You have a soliton, a static field, say, for example, from a magnetar. This is a neutron star which has a very strong magnetic field. The energy of the magnetic field gravitates as well. So you have the gravity, you can read it, actually I can give you sources about that. If you have very concentrated electromagnetic energy, like in a magnetar, you get a gravitational field from the mass itself of the magnet, but also from its field. So I wonder why. Why, if you have very concentrated electromagnetic flux, the flux gravitates itself. In my theory, this is very good explained because it's the same particle. So you have inside this, imagine like a tube here, you have here the gravitons aligned, which makes up it makes the flux line, the electromagnetic flux, but you have also the graviton here, the Berg graviton. So you have in one particle, you have all three forces. You have the electromagnetic, the strong force or the weak force, which are made from 0-point energy of the vacuum, which is actually the evaporation product of the graviton. And these are the three forces. And then you have at the center here is a region of which is very lower, much more lower than 0-point energy of the vacuum. So it's a void of vacuum here. It's a void of 0-point energy. It's not a singularity, but it's a region. It's a hyperspace actually. Here, this region has no energy at all. It's the absence of any type of energy, and because this creates a negative pressure, you have gravity. So as I have said before, gravity is actually the absence of any type of energy, and all the other energies, including the dark energy here, create a negative pressure, reacts like gravity. So you have in one manifold, you have now integrated all the forces, and this one particle here, this gold particle, consists what we call vacuum. So it's a condensate of these gravitons, which are superluminal vibrating. They are not tachyons. They are at rest. They can actually displace. Of course, they can displace, but they are superluminal vibration particles of space-time, consisting space-time itself, and actually any distortion and a coherent alignment of these particles are making up the particles of the standard model. So now here you have each, similar to the previous example with one line, you have the charge flux of the electron each line here is made from coherent strings of these gravitons. And the outer bundle of the gravitons makes up the charge of the electromagnetic flux line of the charge of the electron. And this is true for every particle. Every particle, the quarks, the Z bosons, the W bosons, are made out from vacuum flux. So they are coherent formations of coherent flux from gravitons. So now the elementary particle, the only elementary particle is the graviton. And all other particles are made out from graviton, from gravitons. So yeah, let's continue now here. So another way to understand why the universe, the vacuum must be superluminal, because it binds all the matter, all the non-bound matter and light in our universe is inside the sea of the vacuum. Yeah, and we have strange quantum mechanical effects we cannot understand, which defy this the causality, and we have instant action at distance, with, for example, with quantum entanglement experiments. So this also, for me, it's an indication that the vacuum must be superluminal energy, and all these strange properties of the quantum mechanics are because this this energy of the vacuum is superluminal. So there must be the speed limit. There must be a speed of information, not actually information propagated by luxons this time, but by this dark energy. Yes. So you have this 0 point, the vacuum, the vapor here, which is the 0 point energy. This is Lorentz invariant, but this here, this ring here, is actually what we call dark energy, but the hidden part of the dark, not the energy which evaporates, which is a very tiny part of of this energy. This is the big energy here. Yeah, this is just evaporation product. It's very small. And this is Lorentz invariant. The halo here, the cloud, is Lorentz, so it obeys the C speed limit. It's actually our observable universe, our normal matter and light. And of course, there the limit is the speed limit, the C, the speed of light is the limit. But we have another energy here, yes, which forms some kind of pressure. Imagine now this water is under pressure. And the pressure is mainly the pressure of the dark energy, this superluminal component. So yes, we have propaganda of luxons, information propagated by light cannot exceed the speed of light c, but maybe you have a propagation speed of dark energy, of this superluminal dark energy I described, which maybe can propagate faster and must be, in my opinion, must be much faster than the speed of light. And we actually calculate that in the paper. It's 122 orders of magnitude faster than the speed of light. The propagation of this superluminal dark energy of the graviton is 122 times faster than the speed of light c in the vacuum. And let's, getting down in a more philosophical mood, imagine why I say essentially there must be this propagation of information is very slow in our universe. It cannot be only c, because the universe has a diameter of 26, 28 meters, 10 power of 10. It's enormous, vast. The universe is vast. Yes, and I'm not talking now only for the observable universe, but also from the rest, which is estimated to be about 250 times larger than the observable universe. So imagine that we have a molecule, and this molecule, in order to be a coherent system, a molecule from a plant, from a human, from a molecule, whatever, from whatever substance, a molecule, in order to be coherent, the information inside the molecule must communicate, the energy must communicate at the speed of what speed? The speed of light, which is compared to the size of the molecule, is an enormous large speed. So spatially speaking, Now, this, in order to the molecule, which is very tiny, relative, must, in order to be coherent, must have an energy speed of information transfer very, very large, comparable, the speed of light, which is 8 to the power of 10 meters per second. So now imagine now that the whole universe is a molecule. Do you think that this can be kept as a coherent system by using only the speed of light? I think this is a very logical argument that the universe as a coherent system cannot be maintained without a propagation of information much, much faster than the speed of light. Again, I'm not saying that light can propagate faster than c. The information, of course, propagates when using photons at c. I'm talking now about an information which propagates with this dark energy, which may possible very much that propagates much, much faster and keeps the whole universe coherent. And therefore, we see also this strange, indirectly, this strange phenomena like quantum entanglement, quantum tunneling, and so on. And in general, also the superposition and the double wave particle nature we see in quantum mechanics. They are all imagined effects from this, because this intrinsic property of the vacuum being superluminal. So I have something here else. Okay, yeah. So another unnecessary priority for the theory I'm talking, for my theory, is gravity is now a quantum Planckian force that originates not from matter, but from the vacuum. Finally, what we see as vacuum, I remember, because I told you that for me, matter and light are just gradient, different localized gradient of this vacuum energy. Yeah, and to be exact, of 0-point vacuum energy. Yeah. Finally, what we see as vacuum and empty space is intrinsically superluminal oscillation dark energy that evaporates into luminal 0-point energy, which is the fabric of our luxon spacetime and manifests as matter and light we observe. So the fabric of spacetime Einstein was talking is this 0-point energy vacuum. So it's yes. So this evaporation energy of the graviton is what is the fabric of spacetime. But underneath of that, one level below, we have this superluminal energy, which actually explains the expansion of the universe. And the absence of any energy is creates the negative pressure inside the graviton manifold, which is actually gravity. So let's now talk a bit. Yes, sorry. Therefore, at the end, the quantum field theory and general relativity are not fundamental, but instead emergent theories of this superluminal energy of the vacuum. Yes. Right. Before I go, I have to forget to speak about a very important topic, which is the cosmological constant problem. So this was actually my motive to start this investigation and this research, which eventually concluded to these two papers of the superluminal vacuum energy. So the problem is that, as you know, that the vacuum, the universe expands at an accelerated range, and many say that responsible for that is the 0-point energy vacuum, which, however, increases every year in a total energy sum. It increases, but because because the universe expands, yes, then this keeps the volume density per cubic meter fixed, and this is actually referred as the cosmological constant, which has a value of -1. So every year the space, the Cartesian space of your universe fills up with more zero-point energy vacuum with this vapor, as we can say. But because the universe expands proportionally, the density per cubic meter is the same. But now the problem is from where this extra energy comes from. What evaporates this energy, this extra energy? That's the reason that we call this dark energy, because we don't know the origin, the source of this energy. And here's now the problem. All the theories so far making the specific assumption. They say you have the quantum fields, and the prediction of the quantum field theory and quantum dynamics is that the vacuum energy, when you go at a very close microscopic, it's actually the same problem with the ultraviolet divergence. When you go very microscopic, the energy must be, the calculation must be about 113 to the power of 10 joules per cubic meters. 113 to the power of 10 joules per cubic. That's the calculation of the approximate calculation of quantum field theory. And we observe the expansion to be only -9. So now add -9 power of 10 to 130, you see that the difference actually between quantum field theory and general relativity, our observation actually, is in the order of 122 orders of magnitude. It's the biggest discrepancy in physics. That's a problem. And the problem is how there's no explanation actually for that, and how they explain it. They explain it like that. But this is not experimentally proved, that you have the quantum fields which are in the order of 122 orders of magnitude. And then you have opposite fields, which is at the order of -122 joules per cubic meter, and they cancel out. So it's a fine-tuning cancellation theory. But they're not cancelled exactly out. So they leave a small residue of about -9 power of 10, this small tiny 0-point energy we observe. But this is actually a fine-tuning theory. And I have a problem with that. Many also other researchers don't like fine-tuned theories. So what our theory says is, my theory, is that no, it's not like that. There is a reservoir, a tank of higher energy, which is this superluminal energy of the vacuum, made by this superluminal vibrating. Don't be confused with tachyons. Tachyons are continuously traveling at the speed faster than light. Now we're talking about a very peculiar particle, which is at rest. It's massless, it's spin 2. It's the particle which makes up everything, even space-time itself. It's the fabric of space-time. And this particle is superluminal vibrating, yes? So what I'm saying is that this particle evaporates this 0-point energy. So you have this superluminal energy, which evaporates, radiates, whatever word you want to use, radiates 0-point energy, which is Lorentz invariant. This vacuum here, this vapor, yes, this makes our universe. So it's a total different philosophy. It's not a cancellation theory. We just say that there is in the vacuum is intrinsically superluminal energy that evaporates to a luxus spacetime. It makes up everything. Yeah, that's the theory. And because the graviton continuously, although stable, continuously evaporates a small, very tiny part from its superluminal energy continuously every with cosmological time. Therefore, the universe is expanding. Yeah, the graviton releases slowly this 0-point energy. The energy continues increasing. The total 0-point energy of the universe is increasing, and this expands actually the universe. So it's not a cancellation. It's not a fine-tuning theory. It's just a matter to calculate the the evaporation energy per unit of time of this superluminal oscillation. Of course, you cannot discretely, it's very difficult to quantize discretely this energy and say that, for example, the model is this kind of energy. I don't know, 10 minus 51, I don't know what, yeah? Because remember, this forms a condensate. All the vacuum, the vapor from the graviton, the evaporation energy, is diffused with a vapor from the other gravitons. So it's a condensate, and it's very difficult to distinguish now, to quantize and quantitatively calculate what is the evaporation here of a single graviton, because it's diffused with a energy, with a 0-point energy coming from all the other gravitons inside the condensate. Yes. So that was actually motive. From that motive, I was trying to explain the cosmological constant problem, and this led me to this theory of the superluminal energy vacuum. So now let's see how this is coupled with our luxon spacetime. So you have here our luxon spacetime, which is this vacuum 0-point energy that creates everything, is the substance, the flux, all this, it's imagined like water, like a very calm pond of water, and then you make distortions inside the water with your finger. You make vortices, manifolds, and so on. So whenever this incoherent vacuum 0-point energy becomes coherent, has specific manifolds, then all the quantum particles, the non-particles of the standard model are created, which are not elementary in my theory, just particles made out of vacuum energy. And this consists actually all the quantum fields, all the quantum forces, strong force, weak force, and electromagnetism. And this small energy, this minus 9 power of 10, is radiated from the dark sector where the superluminal dark energy resides. A small, very small component of this energy evaporates and forms the vacuum 0-point energy, which then subsequently forms all matter and light particles in our universe. And this is our luxon space-time universe. However, gravity, as we have seen here, which is very logical, because gravity is actually no energy, that's gravity, it's the relation with all other energies, because here is a void, a hyperspace, it's a void of energy. Yes, you can imagine that like a quantum black hole, yes, where you have Hawking radiation, and then you have the singularity, but it's not, because if you calculate, when you put in the Schwarzschild radius the speed of what we say the superluminal speed here, the resulting Schwarzschild radius is much larger, much smaller than the radius we calculate for our graviton. So it does not collapse to a black hole. You cannot say, because if it's if it will be a black hole, microscope, then it will evaporate at an instant. When you have such microscopic black holes, the lifetime is a few milliseconds. The smaller the black hole is, the radius, the faster it evaporates. That's a problem. But because here we're talking now about superluminal rotation energy, when you put that in the Schwarzschild radius, this speed, 122 orders faster than the speed of light, the Schwarzschild radius needed to this here to collapse to a black hole calculates to much smaller than the radius we actually calculate for our superluminal graviton. So this here is, you can resemble it with a microscopic black hole, a micro, smaller, but it's not actually a black hole. That is actually a good thing, because otherwise it will be stable. It will be, unstable. But because the superluminal property, the graviton is a very stable particle. It's the most stable particle, actually. And it evaporates very, very slowly its energy. And the funny thing is that why it evaporates energy. Yeah, that's another part which is very important we have to talk about. Each with cosmological time, the speed here decreases. This superluminal energy decreases very slowly, yes. And the degradation at the speed of the superluminal speed is actually equal to the 0-point energy. So the 0-point energy it releases is the degradation of its kinetic energy here, this superluminal, this bright component here. Yeah. So we have the superluminal dark energy component of the graviton, which evaporates very slowly in our universe, powers up the expansion of the universe and all the matter and light particles. Yes, because you can now ask, hey, why have an electron and it's there? Why it has so long lifespan, which is billion of years? The electron, what keeps it powering on? Yeah, what keeps it on this? The electron surface is essentially also a vibration. So what keeps this vibration on? What powers this vibration? And I think the answer is obvious here. So now quantum gravity, because it's the absence of any energy, this void here, this here, the quantum gravity communes directly to our space-time. So we have a bidirectional arrow. The arrow is bidirectional. And because there's no, gravity is actually not, it's a relation of energies. It's the absence of energy. Gravity is actually made from the negative pressure of this energy here. So this is communed directly from the dark sector to the light's luxon space-time sector, to our space-time sector. But here you have to be very careful. We see that the arrow is not bidirectional. This is not by design. It's actually because it means that the second law of thermodynamics must be withhold. So if you have a higher energy and it drops down to a lower, you cannot have the opposite, because then you will break. You cannot have the vacuum 0-point energy to return back to superluminal. Yes, where you find the extra energy to do that. So in order the second law for thermodynamics to be withhold, this arrow is not bidirectional. It's one direction only. That's why our universe will have also a finite life. So yes, so this here is in general this described as the energy type is a non-tachyonic cold superluminal, because the graviton can be at rest, although it's massless, and this is just because it's superluminal. Otherwise, this was not possible. You cannot have a particle which is massless and being at rest according. But now we're describing the particle which consists the fabric of space-time itself. Yeah, so you can do that. The temperature-wise, the dark space-time sector is at 0 Kelvin. Exactly. It has no actual temperature. It cannot radiate because in my theory, mass is exclusively a property of the light space-time vector. You have to go at speed at c or lower at c to have the phenomenon of mass. Superluminal energy cannot ever be massive. It does not create mass. So therefore, it cannot have also temperature. Yeah. So and our space-time is the vacuum of the bare vacuum is at 2.7 Kelvin approximate. Our light space-time the 0-point energy vacuum is which is Lorentz invariant and obeys the c-speed limit is at 2.7 Kelvin, and but the dark sector is at 0 Kelvin exactly. You can translate that temperature has no meaning in the dark sector. There's no such thing like temperature. Maybe that's more accurate interpretation of this. Yes. Now about there's another aspect of the gravity of the vacuum and the graviton being superluminal energy, and so on. About the dark matter. So our cold graviton is also a candidate for dark LCD model matter. And why is that? So you have the M64 galaxy, which is rotating I think clockwise. Yes, you see, I think it's similar with our galaxy. Anyway, it's rotating clockwise. But my theory believes that this rotation of this baryonic mass polarizes the vacuum around the outskirts of the galaxy, which acts like a rotational assist. So the gravity gets polarized, vacuum becomes gravitational polarized due to circular rotation of the galaxy, which has a baryonic mass. It's made out of baryons. So imagine all these gravitons around here, which are initially incoherent, not facing in the same direction. And then this mass here of baryonic matter, through a frame dragging mechanism, starts to gravitationally polarize all these gravitons. So now the gravitons around the outskirts of the galaxy are starting to move all in the same direction. So they form a kind of gravitational current here. And this current may be possible assists the rotation of the galaxy observed. So now the speed of rotation starting from the center and going to the outskirts actually gets accelerated, gets assisted, and therefore we don't see here in the outskirts the speed of the rotation dropping, but actually maintained in the same in a fixed value. Yeah. Classical mechanics says Newtonian mechanics says that the rotation speed here, as you go from the center to the outskirts, must drop. But cosmologically, it was observed with telescopes that actually it doesn't drop; it increases and then stabilizes. So that's the problem, and then they say that there's actually some kind of matter. But my theory suggests that the vacuum, this is not just my theory. Many people have proposed that the vacuum itself gets polarized. So frame dragging is a very soft effect. Actually, there was I forget now the name of the telescope, which was in the 70s, I think. They launched a telescope about 1,000 kilometers above the Earth, which was, I think, was it Euclid? I can't remember the name of the telescope, space telescope. And he was measuring for the frame dragging effect. It's a very soft effect. But nobody actually knows exactly, because the calculation is not it's a non-linear effect. It's not linear. Experimentally, we cannot actually prove that this effect is very soft at this kind of masses. So you have an enormous mass of the galaxy, which is moving with more than 200 kilometers per second. The Earth rotates; it's a relatively very small mass, and it rotates with 30 kilometers per second. But now we have a whole galaxy that rotates with more than 200 kilometers per second. So nobody really knows exactly what this can cause to the vacuum. Maybe the effect is not linear, and it gets an extreme boost with this type of masses, so large mass, and with such speed of rotation, such angular momentum. Yes, so possible that the model of the frame dragging is not correct and breaks down to extreme values for such large rotating masses like galaxies by adding this predicted gravitational current effect for such large outskirts volumes of the galaxy. So maybe then the vacuum gets gravitation polarized, becomes heavy, and that's the explanation. So therefore, because my theory describes that the vacuum consists by this dark matter, by this graviton. Therefore, my graviton is actually a dark matter candidate. So there's another possibility, the last one. Maybe it's actually the opposite effect. Maybe this rotation, this massive gravitonic baryonic mass, very fast rotation, angular momentum, maybe it displaces the vacuum here. So you have a region here where the 0-point energy of the vacuum becomes much less than -9, even a tiny bit lesser. But imagine if the vacuum 0-point energy is not now -10 power of 10, but becomes -8 power of 10, one order of magnitude less. Imagine this can have acts like a gravity assist, because now all the baryonic mass is not hindered by thicker vacuum. The vacuum becomes thinner at the outskirts of the galaxy, and maybe that's the reason. That's another possibility. Yes, I have now here to say that in my theory, matter and light cannot exist without the vacuum. Yes? So if you don't have vacuum, matter cannot exist, the same as light, because it's logical. If you assume that everything is made out of vacuum energy, if you don't have a vacuum, then you don't have also matter and light. So imagine this now, that the vacuum is like honey, and it hinders the rotation of the vacuum, yes, of the galaxy. If this energy, this substance becomes thinner, then you can have faster rotation. Yes. Right. A few words about the graviton, and then I will finish. Because somebody may say that what you're talking about is the Higgs field. The things that you're talking about, a field that permeates all space. We actually call that the Higgs field. No, because the Higgs field itself does not describe the vacuum. The theory is that there is the background vacuum, and the Higgs field is another field inside the vacuum. My theory describes the fabric of space-time itself, this unknown vacuum. What is the vacuum? Which I believe if we don't resolve what the vacuum is, there is no such theory in the future of quantum gravity and theory of everything and so on. We have first to resolve what the vacuum itself is. What is this fabric of space? And we don't say ultraviolet divergence, which actually means superluminal energy. That's what the math say. We have to free ourselves from this kind of barriers. So I'm finished now. Just some extreme predictions my theory predicts. So you have here the graviton bare radius. So the bare radius of the graviton is the radius of this bright ring, without including the 0-point evaporated energy, just the ring here. This must be some Planckian length. It's less than 1 Planck length. And we calculate here that the graviton bare radius limit is minus 42 orders less than the Planck length. I repeat, the bare radius of the graviton is minus 42 orders less than the Planck length. The graviton tangential speed, so how fast this here is rotating, how fast this bright red fire ring is now rotating. This speed is 120 orders of magnitude faster than the speed of light. And this is actually the dark energy radiation that I believe can propagate information, not luxons, not photons information propagated via luxons, but now information propagated via this graviton dark energy. This is this is the speed we need in order our universe to be coherent. C is very small for this vast amount, these are vast, enormous, unthinkable distances of the universe. Okay, so this part is very technical. I don't want to speak now about this. Maybe in the Q&A we do, but not in the presentation. The graviton has an anomalous Lorentz factor of half, which is forbidden, of course, and suggests time contraction times 2 the lab frame. So in the lab frame, instead you have time dilation, say times 2, which means that the time it's running now much faster in the lab frame. In the graviton has the opposite effect. In the lab, the time is running much slower. Yes, the bare superluminal vibration graviton out of its effective luxons energy. So this is an effective calculation. It's not realistic. What will be the graviton energy? One graviton be this superluminal energy if it was translated in photons energy. Yeah, effective. And it turns out it's in the order of 181 tera electron volts. But this is not actually, you cannot compare because these energies are out of phase. Yeah, it's I mean this seems ridiculous, this energy, but we're now talking about a different phase of energy. You can say a different phase of matter, superluminal matter. So they are not comparable actually. And what is the bare superluminal vibration of the graviton? Sorry, the luxons mass. So if you have a superluminal energy and you will try now to calculate via the EMC, the EMC square, the non-energy formula from Einstein, the energy equivalence equation, energy mass equivalence equation, then you see that because the energy is superluminal, this results to a very tiny mass. So although this energy is enormous, the superluminal energy, the resulting mass is minus 51 electronvolts, which is nothing. It's minus 51 electron volts. It's nothing. So again, we see here a very important conclusions of the theory that superluminal vibration energy results to actually to no mass, cannot produce mass. Superluminal vibration, that's exactly also why we see empirically, why we see the universe, the vacuum as empty. Because although it is superluminal energy, it's out of phase of our space-time. Superluminal energy does not create any mass. That's why empirically we see the vacuum having no mass and we say it's nothing, but it's not nothing. It's everything. Yes. Yes, and also, again, this has no meaning, this calculation here. The superluminal vibration of the graviton in the particles, in the proper time, the particles frame of reference, is in the order of 207 Hertz power of 10. This is in the particle frames. And because you have times 2 time contraction, in the frequency in the lab frame is actually the half of that, which is 5 times 206 power of 10. So it's halved, the vibration frequency. And finally, the lifespan of the graviton we calculate is in the order of 10 power of 230 years. 230 power of 10 Earth years. That's the lifespan of the graviton because it releases very, very slowly. It's evaporating to 0 point energy. And when the graviton here, sorry, the graviton loses every year kinetic energy, not just every second, but very, very tiny fraction. after 230 power of 10 years, the graviton will, the speed, the tangential speed of rotation will become c. When it becomes c, it will become a photon, and all the vacuum at once will be released in an enormous gamma radiation, and the space-time itself. I'm not talking now about matter, the deep freeze scenario, and that. I'm talking about the end of the space-time itself, when the speed here drops down to c speed, then the graviton becomes a photon, a gamma photon, and then the whole space-time will end in a big flash. But because all this enormous energy is converted to luxons energy, this actually, through the mass energy equivalence principle, is a mass. So now we have an enormous observed mass coming out of the vacuum, and all this mass now will collapse in an instant to a singularity. Singularity, not singularity, something very small. Yes, very small. And then a new Big Bang cycle starts. Yes. This is a calculation. Actually, I actually forgot to include the calculation here. Sorry. Yes, the calculation is here. So, sorry, one moment. Calculation. Where is it? Yes, the calculation is here, and you see the lifespan of the graviton is the lifespan of space-time itself, and it's about 230 power of 10 years, light year. Sorry, Earth years. Of course, the Earth will be not be around at that time, but you get the picture. Yes. That was it, guys. Thank you again. Sorry for maybe I lost the sense of time. I don't know how much the presentation was. Thank you very much. These are this is the newest paper, and this is the older paper related with this research. And thank you very much. And yeah, that's it. Thank you.
Great presentation.
Thank you. Very good.
Yeah, fantastic.
So I guess it's a good idea to leave the slides up if people have questions, maybe.
Would you like to take a break, 10 to 15 minutes break?
Yes, I think it's a good idea.
Okay.
Okay.
Maybe so, a 5 minutes break.
Yeah, 5.
Yeah.
5 to 10 max. Okay, cool. See you
in 10 minutes.
Hallo? Sind dir auch die Augen zugefallen vorhin?
Just working.
Ja.
Five minutes over. I think the others will soon be back. Of course, if they don't disconnect their streams, I just blend. Otherwise, they might have typical fun to reconnect. Maybe we should do a special text training one weekend just for the how to properly connect, reconnect, present button click to professionalize our endeavor here. They lost connection and need to be moved back into the presentation stream.
Christopher isn't online. Oh.
Hello. How are you?
Hello?
I accidentally I pressed I don't know what button and I looked out from the exit from the meeting. That's
As
the
I told you, business as usual. We do that every Saturday when we're connecting.
Yeah.
Press the hot button.
Oh, so now it's okay, right? Yeah, I think.
Yeah, I accidentally put me out of the meeting. I exit from the meeting. I pressed a button there, and I exit the meeting. I wanted just to to cut them.
Yeah, that's okay. You can always come back. That's a good feature.
Well, where is Christopher?
He should be coming in soon, I think. Yeah, he's here.
I put Christopher. I pressed the button and exit accidentally the meeting.
You're still
Christopher,
on mute.
we can't hear you. You are mute. You are muted.
Okay, thanks. Yeah, no, I saw the messages and I let you back in. So, but I was just combing my hair there. So, okay, we're back then, and that was a really good talk, Emmanouil. I enjoyed
excellent.
it.
Thank you.
You can have a Q&A now.
The explanations, the content, obviously, and I like.
Yeah, I mean, the problem is also philosophical. It has become almost a dogma in the community that you cannot research anything else that goes that breaks general relativity and quantum field theory which are constrained by the speed of light. Although all the indications we have is that this is exactly the case. I mean, the ultraviolet diversion they find inside when they do the calculations, and maths don't lie. Maybe sometimes maths are not connected to nature, but I think in this case, this is not the case here. So they calculate, when you do the calculation for the vacuum energy of QED, quantum electrodynamics, quantum field theory, they find this so-called ultraviolet divergence, because, you know, ultraviolet is, in our visible spectrum, is the highest above what we can see. Higher energy, higher vibration. We cannot see that with our eyes. So they bordered the name ultraviolet to indicate actually this fact that the energy goes to infinite. And then they stop there. And I suggest this: no, don't turn around and go the other way, because the math tells you that this is actually the case. So it's possible that the vacuum is superluminal energy intrinsically, and we cannot observe it. I think this is the key point for deciphering the quantum gravity problem.
Emmanouil, when I might make a small question interruption to the preluding the Q&A. I have read your paper actually last week already when I was back from vacation. Superluminal Graviton Condensate Vacuum, it's titled, and I was really stunned to see it's peer-reviewed. So first of all, congratulations to get a paper peer-reviewed with the title Superluminal Graviton Condensate Vacuum. You have really the balls to do such.
Yes, I passed it from more than 11 journals, and they rejected it. And big names, big mainstream journals of Elsevier, IOP Science, Nature, Springer Nature, all these big houses, they all have rejected it, except one from Elsevier, The Dark Universe. But it took too very long, almost 4 months. I had no news, so I decided to drop the submission and go for a smaller publisher. I don't care. I just want the theory out.
Yeah. That is the same one, SPCs, where we published our paper together, and I think they are on a fair level. If you give me 2 or 3 minutes, I would like to bring a quote in from a paper I received from Springer this morning from my friend Harald Gosner. Dr. Harald Gosner is my friend at Intel, who has access to all the paper libraries where I have not. And this, what I read to you now, you cannot read publicly because you need to pay for.
I know Gosner. Oliver, you mean Oliver Gosner?
No, Harald Gosner, Dr. Harald. Okay, and that is extremely related to that what you just presented, and it contains I just want to read the abstract for you. It has a clue, and I would be much stunned if you would not all like what you hear here, because we see that all the big papers, all the big from Nature down, where everybody wants to be, is claiming, no, you cannot publish Superluminal, no, you cannot publish anything which makes even a scratch or a dent in the relativity theory of Albert Einstein.
It's a dogma, no? It's
a dogma, yeah, but it's more a dogma not of the scientists. This is what I'm trying to say. It's a dogma of the editors, and the editors are actually lousy scientists, and that's it. And when you get a Springer document, and I cite here the abstract of a recent Springer document, which in turn, and that is the stunning thing, and you cannot publish such when you do a new paper. It is a work about old papers who had in 1931 wrote quotes, which I want to present to you here. And the title of the paper from Springer Reviewed, recently published, is The Drama of Ideas in the History of Quantum Gravity, Niels Bohr, Lev Landau, and Matvei Bronstein. And the paper is from Gennady Gorelik and was from the Boston University, Brighton peer-reviewed around accepted 11 July this year. And I was completely stunned to read the following on a peer-reviewed Springer paper, because they contradict themselves when they reject papers like yours and allow the full quote of the historic papers telling you, no, don't do that. Everything you do there is completely wrong if you don't allow it.
It depends by the author. If the author is very known and has a lot of citations, that's on that they treat him with different from an
you know, the Hestenes paper, which we talked about on Research, the Hestenes paper had full peer review and was even his way of getting it through with superluminal arguments was extremely hard. So it calls Einstein expression drama of ideas, quote, to describe the history of fundamental physics is especially suitable the problem of quantum gravity, QG. The problem was identified by Einstein in 1916 based on an empirical cosmological argument that was cosmologically flawed and empirically immeasurable. In 1929, the problem was strikingly underestimated by prominent figures in quantum theory, Werner Heisenberg and Wolfgang Pauli. In 1929, Bohr, basing on the puzzling results, recent nuclear experiments and theoretical quantum limitations, hypothesized that the law of conservation of energy does not hold in nuclear physics. The young Russian physicist Landau enthusiastically supported Bohr's beautiful idea, in quotes, which, however, was rejected by Bohr. In late 1932, Landau realized that Bohr's hypothesis was incompatible with Einstein's theory of gravity. This meeting of two fundamental theories prompted Matvei Bronstein to investigate the quantization of gravity in depth. And I mean, in 1935, okay, get that. In 1935, he proposed the first physical theory of quantum gravity for the weak gravity and revealed how deep the quantum gravity problem was for strong gravity. He showed that the gravitational field at a point in space-time is in principle unobservable, and concluded that the complete theory, that a complete theory of quantum gravity would require the, quote, rejection of a Riemannian geometry, ... and perhaps also the rejection of our ordinary concepts of space and time, replacing them by some much deeper and non-evident concepts, end of quote. Until now, despite thousands of publications on quantum gravity, the problem remains a great channel in theoretical physics. And he has this paper from a couple of months ago from Gennady Gorelik, has done in-depth, concise research on all theories of quantum gravity ever published, and he found 400
It's a review paper. Yeah, can you send me this paper?
No, I cannot, because it's not allowed for me to send it. You have to get it by your university.
Oh, it's to be published.
It's published. I can give you the link to that, where to download yourself if you have the rights.
Yeah, of course, the link. I want. Christian, I want the link. Yeah, the link.
Oh, sure, I do that after the meeting. And the interesting thing is there are about 20,000 theories on papers on quantum gravity, all failed, and 400 books on quantum gravity, all failed. Yeah, that's interesting. And he researched that concise. And this sentence repeats slowly: rejection of a Riemannian geometry and perhaps also rejection of ordinary concepts of space and time, replacing them by some much deeper and non-evident concepts. And such a non-evident concept is a superluminal concept about the graviton. Likewise, also I-space theoretical pi3 is 3, 6 around 1 cells of constants of natures, which is evident also that there is some subspace where such Lego subspace would be giving ordinary results of that simplicity for constants. And when we try to publish this I-space style stuff or these superluminal style stuff by the exact same experts, we get rejected because you quoted the word superluminal and because you said, oh, pi is 3, this is not correct, and it's game over. At the same time, the modern paper tells you, get crazy ideas, and even more crazy ideas is better, because only the crazy ideas will be the one which solve the problem. I said, now choose. Would you please choose what you want?
Yeah. I agree 100% with you, Christian. Yeah, the crazy ideas will make the shift in the paradigm.
What I tell you, our ideas are not crazy. They are the one which bring the whole shit forward.
Yeah, of course. Yes, I agree. Yeah, it's a problem with the editors. Yeah, they are very biased. The editors, they are afraid that they get ridiculed by the community.
Anxious about their own reputation. This is not science what they are doing.
You know, in the past it was not like that. You can publish your ideas even if they were controversial. It was much easier to publish this kind of ideas in the past, and that's why
years ago when Archive started as a library or even older, you could just register and publish, and only later, when especially in the quantum gravity arena and the 10-dimensional theories of string theory, they get so many nonsense papers that they wanted to block and sort for the better ones, and it's a bit sad that especially Archive is now worse than a paywall, because the paywall can actually finger point to a person and say this editor is not scientifically sober, let's check someone else or whatever, or at least criticize him publicly if you know the name. And you cannot do that on Archive, so because no one, the mathematical rule is blocking your
it feels like they've kind of shut the door on other people, you know. They've got in and now it's like, oh, keep the door closed so we can just control the castle, kind of thing.
It's a club of local people touching themselves on the shoulder and said, wow, we are so cool.
Anyway, we have to try to keep knocking the door until it falls. That's the way to do it. And there's a saying in the community that a theory dies with his creator. A theory, of course, that was
unfortunately with Albert Einstein. It wasn't true for the last 120 years.
But
and then there's the other saying about
sorry, I just want to say something.
Yes, go ahead,
don't confuse. I mean, a theory of it's a beautiful theory. The theory for Einstein is it's the best things we have, but it's incomplete. And the same is for quantum field theory. And you know about how the tachyons behave. Now we go to tachyons going past but these are just predictions, theoretical. Nobody have seen actually a particle going to the past from future to past. And by definition, if a theory is incomplete, it must also have false predictions. So it's not sure. We don't know how a superluminal particle behaves. 100%. It's not sure. It doesn't mean that it will comply with our known theories. And all these predictions about tachyons going back to time, they are the theory calculates these things, but we're not sure. There's no experimental verification. Remember, for gravitational waves, we waited 100 years after Einstein. Only after 100 years, with LIGO, we experimentally verified his prediction of gravitational waves. Doesn't mean that if a theory predicts that something cannot be superluminal, that it's also correct. And by the way, about space-time, Einstein doesn't say that space-time cannot be displaced superluminal. Of course, it can be displaced to superluminal, and we see that actually cosmologically. We see the expansion of the universe after I don't know how many megaparsecs. We see that the space is expanding superluminally. Yeah.
Well, that was the quote I was trying to remember. There was it science similar to the one you mentioned? Science progresses one funeral at a time, or something.
Yes, exactly.
Until the old guard dies off.
That's more accurate.
But I wonder, they obviously know that because it's repeated so often. That I think they might have even gone so far as to close the loophole on that, because I mean,
I believe it's also a good thing. The science cannot be rushing. It's not a bad thing. But the thing is that we have to keep trying. We cannot abandon this. We have to knock the door until it falls.
But I suppose it's good to that everyone can I see what you mean. But So how strict? It depends maybe on how strict it is, or
like
should everyone be allowed to play here or whatever?
It was more liberal in the past, more liberal, to publish something. And when you see the superluminal publications, they are very dense in the past. I actually have written more than 200 papers with superluminal research, and most of them are from the 70s, 80s. That after the 80s, but 90s, you see a decline of these papers. Yeah, but the problem with these papers is that they're talking about tachyons. My theory is not tachyonic. It's not a tachyonic theory. Yeah, because you cannot describe the vacuum as tachyons.
Okay.
But again, we cannot know. The problem is that a tachyon must continuously move with a speed faster than light. And then you cannot have a condensate. You cannot have what is this? Just continuously moving where? You have to. In order to have the vacuum, you have the particle must be at rest, and then, like water, and then it can be displaced. Yes, that's no problem. But you cannot have a condensate, a vacuum condensate with tachyons, with just tachyons. No, but again, we don't know that. Okay, the theory suggests if you are a tachyon, you have to move continuously. No, but empirically, experimentally, we have not verified that. That's just a theoretical prediction. Yeah. So we cannot say. Again, I say that if everybody agrees with that, both quantum field theory and general relativity are effective and incomplete theories. And by definition, an incomplete theory must have also wrong predictions. So maybe that's one of the wrong predictions about superluminality these two theories have. But again, you see, they contradict themselves, especially quantum field theory. They say there's no superluminal propagation of information, but then you have this this non-locality, which is which can be also translated in some superluminal propagation of information. If you have a propagation speed calculated 122 orders of magnitude faster than c, that's instant. I mean, in the galactic scale, is even in the cluster scale of the universe, it's instant propagation. You imagine what that is kind of speed. But this is actually the case for a molecule. A molecule, in order to be consistent, you have all the information there. The energy must be propagated with the speed of light. The speed of light is 8 power of 10 meters per second, which is spatially, it's enormous larger than the size of the molecule. So now imagine that the universe is a molecule. Yeah, the universe is estimated. The observable is 26 power of 10 meters, that order, and the whole universe is 250 times larger. The whole, they estimated to be 250 times larger than that. So it's about, I think, 29 meters power of 10, the radius. Yeah. So now imagine that the molecule is our universe. What speed do you think propagation of information is needed? This molecule, the universe, to be consistent, not to break up. You need c is now very small speed compared to c. The speed of light now is a very slow speed for the propagation of information. So now you need a medium that propagates the information much faster. And I suggest that is the dark energy. But not the dark energy which evaporates to 0 point energy and expands the universe, which is not, that's not. They actually believe, not just me. This is the consensus currently. I can say that the vacuum 0 point energy is responsible for the expansion of the universe. The difference with me is that I say that it comes from there's a hidden sector, dark sector, and there resides a mountain of dark energy, but which is superluminal, and we see only at the tip of the iceberg in the form of 0 point vacuum energy. This tip is Lorentz invariant; it obeys the speed limit of c, but the rest of the mountain is superluminal hidden dark energy. That's what I suggest.
If you allow, with that, I would have a question which sounds a little bit critical to you, and it is not, interestingly, because I also think superluminality is a thing of eye-space theory. To synchronize all of the subspace cells is not possible with the speed of light. The gears would have, think of a mechanical gigantic gear, it would get friction one way or another, but when you have a much higher speed, like in the eye-space theory is 10 to the power of 27 meters per second, what I calculated recently. And it's not so important on that thing as such, but you did a step 2 theory, in my point of view, by jumping over step 1, when you say we need a theory on a higher level to condensate quasi all particle theories from that to get ordinary matter. So quantum gravity theory is, if you want it or not, a combination, at least on a logical level, from theory of relativity and quantum mechanics. And if quantum mechanics is incomplete, so be it. Then we add eye-space theory to it and make it more complete. And then we have constants of nature. So we add something to theory of relativity and make it more complete. Ouch, stop. In the article I just told you, it is clearly said it is incompatible if you ever quantize quantum gravity to Riemannian geometry, and eye-space theory is fully compatible to that. But last time I looked, relativity theory from Einstein is not compatible. It is only Riemannian geometry and nothing else. And when that is incompatible, you either have please to drop Riemannian geometry with dropping Einstein completely and do your own stuff, or not. You cannot merge gravity with quantum, with relativity, because it has proven for 120 years to be incompatible. It's the wrong approach to even try to be compatible to it. You shouldn't. So, but from your point of view, it's irrelevant because you have overjumped this little step of uniting the two theories in one way or another. And said,
I don't care. I don't care to unite them. Yeah, I don't care to unite. I want to
exactly. It's useless to try to unite them, and that's why
I just want to describe the fabric. That's all. It's a materialistic view. My theory is, I assume that the vacuum is a material.
Which brings me to the more important second question of mine: is how the hell do you condensate structures like, let's say, hexagonal eye-space style Lego style particles out of that? So where are the boxes which finally give the standing waves in form of whatever analog energy or?
Yes.
There is too much randomness in your theory where I can't see how the condensate should reliably produce particles by will or whatever process that should be. This is what I cannot see at all at the moment.
Yes. Okay. So all the particles of the standard model, which are not elementary according to my theory, are distortions in the vacuum flux energy. And when we're talking about the the particles of electromagnetism and the strong force and the weak force, the three of the four forces, these are made from not from the graviton, the inner part, which is the absence of the old energy. It's just the mantle. The mantle, which is the evaporation energy, which is the 0-point energy, is the substance which makes up the particles of the strong, weak force and electromagnetism. The final force is a combination of where you have the ring, you have the absence, the hyperspace, which is a void of any energy, and the gradient between the dark energy and the 0-point energy makes up the gravity.
I think I completely get that point, Emmanouil. The problem I have with that is not the principle-based model. It's a very, very clever one, in my opinion. Especially that gravity is nothing and being a negative pressure is really clever, in my opinion. But you need structure. And structure is not, or maybe it is. I'm not saying it is not. Maybe
I see.
So structure from chaos is possible, for example, in Wolfram's NKS rule. Rule 30 gets absolute perfect structure out of absolutely nothing. So mathematically that is possible, but when you have randomness in there, not in the Rule 30 Wolfram randomness style, but true randomness.
Yes, I understand.
It would be random forever. Why would it organize?
I understand you now completely. The graviton, you cannot imagine the graviton having a space between one graviton. It's a boson. So a boson can't be on top of each other. It's a mess, actually. So, because if you say that the space itself is made from gravitons, You cannot introduce space inside the graviton condensate. I mean Cartesian space. There's no this separation between the gravitons. They're all together because they're making up space. Yeah.
So I have a problem with your condensate or foam. Is it possible that your gravitons are arranged?
Gerd, I have to answer Christian's question.
Okay, we'll come back to Gerd then.
I have problems to get the word because some others are speaking very long.
That's true. I wonder if you could just remember how much more do you need to answer that question, Emmanouil? Is it not longer?
Is it possible that
just a few minutes? A few minutes.
I will write you an email. It's better in text. I have problems with English, and it's not good if I stopped when I.
I don't know what. So, Emmanouil, you could answer both questions. How about that in one after the other?
Yes, I'm not finished with answering Christian's question. So there's this, yeah. So this imagine like water, I see, and the molecules. You have the molecules of the water, and then you have radiation energy. Between the gravitons, there's this radiation energy of the dark ring, this fast fringe. But
are you answering my question or from Christian?
Yeah, we're going to get to your question next, Gerd. So just keep it in mind, and we'll get to you straight after this, a minute or two.
So I understand that you imagine space in your theory as having specific geometric structures. The structure of mine is a ring, but it's a mess. It's not even. It's incoherent. They're not like they're bosons. One ring can face this direction, the other ring can face the other direction.
That's not my question. Yeah. My question is totally different.
Okay, I think you answered that question anyway. Yes. Gerd, you go ahead there.
Is it possible that your cold gravitons are arranged in form of crystalline lattice?
No.
That's a need for.
They're not polarized. Inside the vacuum, they're not get polarized.
It's a need for polarization. Yes,
they get polarized. They get polarized to a particle of the standard model when they become. They have.
Yes, but then you need a crystal lattice to polarize, and if you have a foam or any condensate, I don't know how to polarize. It's impossible.
Yeah, there's no polarization inside. At rest, it's acting just like one atom. That's the whole thing about the condensate. The atoms, when they're cooled enough, the whole.
The atoms are in form of a crystal lattice.
Like one, yeah. There's no lattice actually. There's just one atom. Yeah.
Yeah, actually, one of the things I just want to point out is that two things. I mean, people are close-minded. I mean, but the other aspect, main aspect, is that I would think everything is noise, which means that that's the reason. You know, even superluminal thing is noise because when you go above,
the 0 point energy is noise. Actually.
Noise, yeah. So what happens is, how do you create something from the noise? So I have, I think, briefly described the concept is that locally there's some distortion. You can actually prove, I mean, eventually mathematically, that any random process will have a local distortion.
Defects in the medium, like defects
in the medium.
Localized defect in the medium.
Yeah. So that you can prove actually mathematically. I think it needs a very high math, but I was thinking about different ways. But actually, you can prove, like in the Z, right? In the sea, you have everything is turning around, like Atlantic Ocean, Pacific Ocean. But inside somewhere, there is a vortex was possible. So inside And I have given a way how the vortex can form. So when it's turning around, it's longitudinal waves, but locally it can create a vortex field. It's a gradient that creates locally a vortex. That vortex is sufficient to start the whole process. So you need only a minor perturbation. It's a perturbation in the noise. You need only a very minor perturbation. And if you can hold up, this is proven even in the, when I do material science, like nucleation growth.
Yeah, you can have, you're referring to solitons.
Yeah.
Electromagnetic standing waves, for example, can form a self-sustained soliton, which is actually a wave particle. A soliton is a macroscopically localized area, like a sphere, which is made out of electromagnetic flux, and it's self-sustained. It doesn't need an external energy. That's the general description.
Which brings us back to the origin of my question, if there is at the core of your theory the idea of self-organization, because far from saying that is not possible, not the faintest. There are experimental evidence of magnetic superfluids, which you have in a bowl of magnets, which is rotating with a high frequency. And I can show you the video in YouTube of that. It's a real experiment. When you rotate the seemingly completely fluctuating superfluid, magnetic fluid, and you start rotating in hexagonal I-space style cell structures, start automatically from nothing out of the self-organization within the rotation of the bowl. And the bowl only rotates on the edge of the fluid, of course, in the beginning.
Yes.
This is very interesting to see that out of really true nothing, such structures can arrange.
Yeah, the problem is, again, I believe what also is referred as leptogenesis. So how all this, if everything is distortions in this vacuum fluid, when all these particles, matter was created, so it's some kind of phase transition going from water to vapor and so on.
Well, like water to ice, which is the obvious phase transition.
Yeah, what caused this phase transition? So even today, the consensus is that the beginning there was the vacuum, and then the Big Bang actually was a phase transition mechanism. It's not that it was started from one point and so on. The whole universe was very small in the beginning, and then we had the spontaneous phase transition. What caused this phase transition? I don't know. God.
So, yeah. I mean, I do agree with that. Yeah.
So
that's possible.
I don't know.
No, I don't rule out that possibility.
But the problem is, if you have an electron, okay, you say it's a soliton, and soliton is self-sustained. I mean, it's a wave particle, a standing wave, which does not need external energy to continue what it's doing, its vibration. I find it very hard to believe. Sorry.
Okay. Yeah.
It must be powered from somewhere. So in my theory, this somewhere is the vacuum energy itself. So the 0-point vacuum energy, which is always on the move and continues this. It's similar to our planet, which continues to orbit for many billions of years around the sun. So these particles, but the source, the origin of this energy is this superluminal dark sector energy, which gets converted to a 0-point energy. And another thing is that in the large scale, the cosmological, the conservation of energy, the community says is not preserved. That's the consensus. Because the dark energy, they don't know from where the dark energy comes, and therefore they see just the energy of the universe each year increasing, because the amount of the total 0-point energy is increasing every year. That's why we have the expanding universe, and it's expanding. It's increasing with a density fixed. So the energy density minus 10 power of 10 per cubic meter, it's always the same. But because the energy, the 0-point energy is added every year, you get the expansion. That's the whole thing. But that's also the reason why they're telling that the conservation of energy is not preserved in the large cosmological scale. My theory says because there is an extra reservoir tank hidden energy, and that feeds all this powers up the universe. I believe that's logical. Instead of saying this, I mean, this is a bit extreme. You say that you have a 120 orders field energy, and then you add a minus 120, and then you say they cancel out, but they're not cancel exactly out, and they leave a residue of minus 10 power of 10 0-point energy. But this is fine tuning. Okay, but until now, one of these theories is SUSI, supersymmetric theories. That's the suggesting. They're suggesting there are particles, companions, and they somehow they face in the Fourier and cancel each other out, the oscillations, and then you have the 0-point energy. But there were no supersymmetric particles found in the last 10 years. After the Higgs boson discovery, which verified the Higgs field, which I have to say something about that. The next step for the LHC was to discover the supersymmetric partners, which will prove this assumption that you have a fine-tuning cancellation. That's the origin of the origin of the 0-point energy is nothing special. It's not coming from somewhere hidden, but they're just all the quantum fields. There are another quantum fields that cancel each other out. That was the concept. But in order to prove this, you have to prove, especially under the context of the SUS theory, the supersymmetric SUS theory, you have to prove the existence of supersymmetric partner particles. Well, the last more than 15 years, nothing was found.
Not even neutrino.
They're still saying that they have to step the power of the LHC accelerator even higher.
Oh, well, of course they can do that, can't they? Because isn't there a thing where the 0-point energy from the conventional point of view is undefined? So it could be any value, right? So does that mean that the particles could have any mass, or what is the story there?
Well, the cosmological constant is they measure the expansion of the universe, currently about 74. I remember it's 74 kilometers per megaparsec, something like that. I can't remember now the exact figure. From there, they extract the vacuum energy, which is about minus 9 power of 10 joules per cubic meter, which is a very tiny.
Oh, of course, yeah. I think I'm talking about the quantum field theory version. You know, in that it's either infinite, but then you can, as you were talking about, you can remove the Planck length.
Yeah. They put cutoffs.
Yes. Okay, so then you reduce it a bit more, and then
they put a Planck.
Yeah, then you also have the idea that it's if it's a harmonic oscillator field, that's unlikely. So there's particle interactions, and then finally they just say, well, it's undefined because the energy could be anything, right? Because isn't there the thing, we don't measure the energy, we measure the difference between the difference of energy. So I'm assuming that's the potential versus.
Yeah, but you still have to assign a ground. You have to still assign a ground. So they assign the 0-point energy fluctuations, whatever that means. They assign it to 0, and they start from 0 because.
You can do that, but you can also just say it's undefined because it could be any value because they don't have a grand.
You need a zero reference. You need a zero number. You need a zero number. You cannot. You need.
But I think they could a bit like maybe with the Higgs field where it has a non-zero expectation value. You could have this grand floor of the.
I think you're wrong because they have to go to Kelvin, and the CPE will be at near 0 Kelvin, but not 0 Kelvin. You cannot define it to what you want, and we're talking about two totally different things.
No, we're not. We're not. This is like the top level of this conversation. You get to that the vacuum energy is basically not determined.
Yes,
so
you have the Heisenberg uncertainty principle. You have the Heisenberg uncertainty. Of course, there is a 0-point energy, which is regarded as scalar field. And then you have the 0-point fluctuations. The 0-point fluctuations are this what we described. Oh. Yeah, the ZPF. ZPF is exactly what this you described, which is also the source of the Heisenberg uncertainty principle. Because it's
okay, yeah, but I don't think. This is more to do with like if you have vacuum energy density in quantum field theory, then in the and if we are neglecting gravity, so that's important from the what I was speaking about earlier about we only measure the differences in energy. That's a problem if you include gravity. So that's interesting. This means we are free to add any constant whatsoever to our definition of energy density. As long as we are free to do this, we can't really say what the energy vacuum density is.
Christopher, exactly. You are exact about the gravity. Why you don't include the gravity in the vacuum? Because the community says that vacuum is not gravitating. So vacuum has no gravity. Only matter has gravity.
Okay.
That's the problem. So you don't need to include gravity in the calculation of 0-point energy. But that's exactly the problem.
Right.
Because in my theory, the gravity sources out from the vacuum. It's intrinsic property of the vacuum, not of the mass. Mass is just when the vacuum energy concentrates and makes these manifold elements, it's just a gradient of the vacuum energy. So it's the origin of the gravity is not in the matter. The origin of the gravity is in the vacuum. Everything comes out of the vacuum. So we have a difference here.
Is it possible that gravity is negative vacuum and the opposite is the what we see? So you have negative vacuum, positive vacuum cancelling each other. So negative vacuum creates a negative pressure, which is gravity, and then you have positive vacuum, which creates positive expansion of the universe. So you have.
Yeah.
Yes, but when I come back to the question, very interesting question of Christian about the structure when the vacuum is at rest. There's no matter in the vacuum, so this is just noise, incoherent. The gravitons are in a mass. They are not mass. They are mess. They're incoherent, like bosons. They can be on top on each one. They can face in a different direction. So whenever these incoherent gravitons become coherent, meaning they are lying in some way in a manifold, then you have mass, you have matter, and you have even light. Because light, if you see in my previous paper, my manifold for the light is a ring as well. It's a 2D circle. The manifold is just a vacuum flux that bends and makes a loop. It's very similar to the manifold of the graviton. The only difference is the graviton is superluminal spinning, and the light, the photon, is spinning at C. That's right. That's the difference. Yeah.
So it's gauge invariance. I think that's an important factor. They both have gauge invariance, and photon and graviton.
What you seemingly overlook here is that the charge as such is a quantized entity and is undoubtedly, and we hopefully all agree to that, comes in pairs. So the old theory of conservation of energy is a nice thing, but it basically comes from the conservation of charge. You cannot create an electron without creating a positron, and that's it. Which means you need to find a way to get soup into structure. And soup is then a soup of positrons and electron pairs, which interesting people like at ResearchGate had a lot of discussion with these guys on a very interesting discussion group with Frederick David Tombe. It says everything is subspace style, like iSpace style structured, and is a soup of electron and positrons in a geometrically organized way, which doesn't annihilate. And that is what iSpace is also saying for different reasons. If they don't annihilate, then charges tend to structure themselves by their forces. And how they commit the forces by your electric field lines is another thing. which was part of my initial question, but you interrupted me before I could complete. When you make an image which has the manifold image of an electron, and you know, because we wrote the paper together, then it's your analog view of that what I-space theory is saying on the discrete side purely formally, so that the numbers fit. From an analog picture, it's hard to say that the numbers fit, but you get the same logic. If you have a ratio of two fluxes, then a ratio of two resistances makes no difference, basically, because you're saying essentially the same thing. But your fluxed graphics is violating physics in a way when you carefully think about it, because one electron has exactly one flux. Because we have a definition in a SI unit system where the definition may be wrong then, where you have Tesla per square meter. And if you have exactly a quantized Tesla in a unit system to be defined, then it would not be a SI Tesla, but 1 electron per square meter or per square unit. Mm-hmm. And then I guarantee you, you can read in any book you like, that you have quantized fields lying through the area of your measurement of the square meter. Mm-hmm. And there is no exception to that, because it enters the area, tunnels through the area somewhere around, comes back from the top side like in your graphics, and it may wind up, of course. Yeah, that is true. But then the graphics would have to, I cannot see it from your graphics. Is it geometrically wound up along single line? Then it's okay. But you
along
always
a single line, yeah.
Multiple fluxes. I cannot agree to multiple fluxes. It's a single flux.
Oh yeah. Of course. That's just a toy model. So imagine. So you imagine you have a ball of sphere, and the lines are just indicating the flux of the water. It can be diagonal, but it's just one. Yeah, of course, the flux is one. It's not simple. The lines are just not to indicate the flux of energy, but the charge of the flux is just imagine one surface of water. There are no lines, but the water has a directional flux. It can be diagonal, it can go up, it can go. That's what the lines are indicating. It's indicating the flow of the charge.
Important is this charge is quantized. So what I cannot mentally do, that maybe because of my non-physical string theoretical training lacking and all that, what I lack in theory of relativity, but I know quite a thing about quantum mechanics by the time. And a quantized thing is easy to visualize for me, because when you come with the foam stuff, well, I have a hard time on how would it self-organize. When the foam stuff is a mix of charges, I can visualize myself in a
the Graviton has no charge.
That is the problem of your theory.
Has no charge. Yeah.
Where does the charges come from in this kind of theory when everything is
the charge of the electron? When you see the toy model, is just what we actually mean by charging something.
That's
moving towards him.
There need to be two type of particles from your model, not one. You need electron and positive.
No, for the space-time, for the particle which is describing space-time itself, is one particle. It cannot be more than one. No. If you want, I disagree now. If you want to have a theory of everything, you believe only in one code. There's one particle that makes everything. If you introduce forget it.
Yeah, but you have to tell how positron and negative charges, they are not a geometric orientation in higher dimensional space-time. So now you could argue a positron is upwards and an electron is downwards or something like that, relative to a hypothetical geometry of the overall universe.
Let me show you my. Can I share the screen again?
Yeah.
This is not a light question, Emmanouil. This is the killer question to your argument. If you cannot show how positive and negative charges appear out of nothing from your model, I don't believe it.
See, one of the problems is that distortion. The charge is created by the distortion. So distortion separates the neutral, zero charge into two different charges.
Yes, Rajan. In what direction of 1, 2, 3, 4, 5 to 10 dimensions? You cannot argument with this in a random equilibrium style mess. I don't get it.
Well, you are longitudinal waves, right? Longitudinal waves. Then you create, it's like modulation. You can think of a radio wave. I like to think of a radio wave where you have carrier wave, right? And then you have modulated wave. So when we transmit a radio wave, is a modulation that is being so when you modulate that and it's enough amplitude, it goes there. The same as sound waves, right? So the modulation, you can create positive and negative. You see that in terms of wave theory.
No,
you can
I don't see that,
Yeah.
Rajan, because even the
Negative
wave
anyway.
Have you seen my
of an
screen?
electron going forth and
Hello,
back
hello.
is not a positron
Well,
involved.
when you have
Side.
positive and negative anyway, because you've like, you know, your wave is going up and down, like, so why do you need the modulation?
The wave comes after the electron, so the wave model is nice to visualize, but
sorry,
you never explain the core electron-positron dipolity as such.
Christopher.
Yeah.
Sorry, I will stop here. Goodbye.
Thanks, Gerd.
Oh, thank you. I see you.
Questions.
Yeah, we'll see you again next week.
Okay, so this very interesting line of questioning here. Oh, Emmanouil, you're muted. Sorry.
Can you share my screen?
Sorry. Yes, you're shared now.
Yeah.
Go ahead.
Okay. So, okay. Can you see the animation here?
Yes.
Can you see the animation? Yes.
Yeah.
Yes.
So,
yes.
if I understood, Christian asked about the charge. So this here is the electron. Here is the spin-up version. This here the magnetic moment. Yeah, the electron has minus one elementary charge. This is a spin-up, and here's the positron. Can you see the difference in the charge of the plus?
I can see, and adding to the question, what stabilizes the north-south orientation?
Look here, look here close.
Don't overtalk each other.
Christian, look very closely. Here you have the magnetic moment of the electron up, yeah, and here I have the same direction of the magnetic moment. See now how the flow is, how the charge is going here in the positron, and how the charge is going here in the electron. Can you see the difference?
Yes, I can.
Can you spot the difference?
Yeah, they're cyclically rotating in a different direction.
No. You miss the difference in the detail. Look here. Can you see the magnetic lines here, which represents the general flow, are leaning to the left? That's why the handedness is also left-handed, not the chiral.
They are left-handed.
In the positron, you see the lines leaning to the right.
Yes.
That's the difference from this is the minus E charge, and this is the plus charge. The charge itself is this motion of the flux. That's why also the name charge comes from. I'm charging towards
Emmanouil, but
charge,
then
you know,
from
it's kinetic energy of flux. It's kinetic moving flux. Kinetically moving flux.
From a conservation of momentum, when something starts to rotate right, something else needs to start to rotate left. That is, I think, the core heart of charge separation.
This is for a luxon spacetime. It doesn't apply for something which describes spacetime itself. Yeah, the different.
Without 10 dimension, you will have a hard time rotating to the right and to the left at the same time at the same spot in space. So.
But you have you can have so what you can have the graviton rotating clockwise. You can have it also rotating counterclockwise. That's the problem. Is that solving your question? So you have the ring of the graviton rotating clockwise, and you have another graviton which is rotating counterclockwise.
But it is not a random effect which allows the positron to rotate counterclockwise and the electron clockwise, because they have to do that synchronous creation of the charge out of nothing. So when you have the energy and create in the experiment one electron positron pair, which is a trick because there's an atom nearby, which like a catalysator does that.
Yeah, I agree with you. There's no problem, but this applies to our spacetime. We don't know the physics of the superluminal vacuum.
I see what you're saying. You're saying it's irrelevant what you make in the higher superluminal spacetime because all the other rules still apply in the way we do.
Look, Christian, I don't care about what the charge is inside the superluminal fluid. I know now. I have now the electron. I agree with you. You have to the partner. You have to the antimatter partner. Positive, the positron with the electron. That's how it comes out from the vacuum in our space-time as a particle, antiparticle pair, and then annihilates back to the vacuum. Yeah, something like that. Annihilates to photons. Okay. I agree with you. That's one. Now I'm in the space-time. Now I'm describing the fiber of space-time. Now my only concern is to describe what these lines here consist. What are these lines? So I'm telling that each of these lines, which represents the general flow. Of course, the electron is not lines. It's the whole surface. It's just the motion of the fluid here, of the flux.
You now just said all these lines. Yeah. Would you please correct yourself that we are on the same bus? That this is a single wound line.
Yeah, it's not. Each point of the line is a graviton, and they are aligned. They're making a tube. The outer mantle of the graviton is the flux. Yeah. So when I solve this problem, then I have to describe the the charge flux of the electron using my graviton model. That's all. So imagine all this flow, each point here that flows in this is made from gravitons. They are aligned. The flow is aligned now towards this vortex.
Each point of the surface, human word says two flux tubes by counter rotating right-handed and left-handed make that up what the electron is magnetically, electromagnetically comprised of.
Of course, it can be a cube. Of course, the manifold of my graviton can be a cube, but I thought it was a ring. Of course, it could be some.
Is it quantized rings which add up in a microscopical way to the line, or is it a tube which?
The rings make up a tube. The outer mantle of the graviton
is a quantized entity from the point of the. It needs to be right. So.
How does a ring make a cube? I'm losing you here.
How a ring makes it? Okay, if you have a tube, a straw, you can break it, cut it to rings. No, yes or no?
Oh yeah. So there's ways of doing that, of course. I'm just losing the entire kind of that's not a big issue. I am a bit confused. One part geometrically on this, though, you have the nice spinning model there, or you did, of the electron. And then, but you're saying at the center of the graviton there is emptiness, like hyperspace. But when it's part of the electron, obviously presumably has to be bigger.
Each flux line has also gravity within.
Okay, but are they also? They're not interpenetrating each other, are they? They don't go through one another. So there's no. Is there any issue there?
Not when they form a specific manifold of vacuum flux like an electron. Then they become coherent and aligned.
Okay, so they don't go through each other. They don't.
No.
They don't go like that or anything.
No, they don't. They are bosons. They can collide. They can collide, but you cannot. They cannot tangle together.
Right. Yeah.
Because the energy is too. The energy, the fire ring inside. The energy is very, very high. They cannot.
They cannot penetrate, right?
Of course, the energy is very high. It's traveling at superluminal speeds, and the speed you gave was 122 times the speed of light. Correct? I'm just interested. 10 to the power of 122.
122.
They are traveling at that speed. They are rotating at that speed.
They're rotating.
True. Well, the energy rotating inside is.
But they can actually then displace linearly like that.
Okay, but so then from your equation, it seemed like you got that from the difference between the quantum field theory value for the vacuum divided by the.
And the observed, the observed there.
So, what is the logic behind doing that? How did you come up with that idea? I don't understand. It's interesting to me.
Yeah, it's. I think it's in the mathematics there. The effect must be analogous because the energy we see in the Einstein mass equivalence relation. There's the speed there. There's a speed factor. So if you divide these two, they get, and you say the mass we observe of the vacuum energies is 10 minus 10 power 10. So they get cancelled out, and you get a pure speed radio. Yeah.
Okay, so you are doing a cancellation then.
Derived. Yeah.
In some sense. Okay, so normally if you're getting a speed, you're like distance divided by time or something. You seem to be dividing one possible value by another.
Yes, I get the Einstein equation of mass energy equivalence. I make the ratio, and the masses cancel out, and there is only a pure speed ratio remaining.
Oh, okay, yeah, because I mean, there's some interesting calculations you did for the energy as well. So, but you're using the radial diameter of the graviton, and so, but if normally with like other kinds of particles, normally we don't have that radius, do we? We might have the classical radius.
Of course, they are pointless. Yeah, but in my theory, the graviton is a particle string.
I know that. I'm just wondering. So you couldn't apply the same equation then in other areas of or in general, like they wouldn't be able to do that in quantum mechanics or something.
Well,
where they would
that's not exactly true, because even in conventional, the mainstream physics, using the Compton wavelength to calculate the energy. So it's effective. It's an effective method, to calculate.
And that would give you the radius value.
Yes,
the Compton?
It's the radiation radius. The Compton wavelength actually is the perimeter of the particle in my model.
Sure. Right. Okay. That's very interesting. So then, and so the two H bar C, that's just standard kind of.
Yes.
Thing,
except the two. Except the two is my addition.
Right.
Because the spin 2, the graviton has a spin 2.
And
the equation we're referring without the 2 is applied only for photons. So if you want to assume that this equation holds also for a spin 2 particle, you have to add also the spin, which is 2. Photons have spin 1. Photons have spin 1, That's why if you want, because it's an assumption, it's heuristic. Nobody tells you that you can take this equation and apply. But my guess is that it also applies for the spin 2 graviton. So I adopted the equation to match the spin 2 of the graviton.
Right.
Because
so
the energy, the Planck frequency energy equation it's referring only for photons. You have to convert everything to photon energy and then apply the equation.
Right. So
but
you
I
can
apply directly the equation.
But it's useful for certain bosons or all, like maybe not all bosons.
Yeah, you can every fermion you can convert its energy to photons. That's actually is the whole meaning of the Compton wavelength. Is the Compton wavelength is the energy, the wavelength a particle would have if it had the same energy with a photon. It's an effective measure of the energy of every particle. Every electron fermions, yeah. Nice. Because if you crush an electron with a positron, they annihilate, yeah. And do you know what comes out from that annihilation?
Photon.
2 photons, yeah.
Okay.
So you can. So now you can, if you calculate the Compton wavelength, you can refer back to the energy of the electron.
Okay, cool.
Yeah.
Another issue though was not an issue, like, so these are just questions. So the point was you mentioned that the graviton.
No, I'm very interested, guys. Actually, because I cannot find for myself all the implications.
Yes,
so I'm very grateful even for Christian, and I believe Christian, come back to your question. Sorry, Christopher. I believe your theory of ice space is even deeper than mine, even deeper, because I explained. You could ask actually the question, and I was actually surprised you didn't ask this question because I know you have a very analytical mind. Okay, you say you tell us that the graviton is a ring, and then this fire ring, and this is the dark superluminal energy, and this is the fundamental and the only particle of the universe. Yeah, so you could actually ask me, okay, what is this fire ring consist of? Yeah. I mean, there must be another particle there, right? I mean, you have the fire. You said it's a superluminal dark energy, and this is the fire ring. So this
interesting is would we agree when we say it consists of waves, or would we agree it consists of something we don't know? It is energy, so
Yeah,
it is necessarily some way of weight.
It can be, in our case, it can be hexagons. It can be.
It could be hexagonal waves, because hexagonal waves are circles in ice space, and circles are valid
of
waves.
course.
So that's it. Yeah.
Okay, that's interesting.
Yes, of course. But the thing is that at some point you have to stop. Yeah, at some point, if you have now explained the theory and you have united, you have a quantum gravity theory and you have united, because no theory is complete theory. All theories, there's no complete theory. So you have to put a barrier in some stuff.
Your model is very, very interesting.
However, sorry, let me finish, please. The problem, however, is with the current situation that they put the barrier very premature. They put a cutoff to the speed of light. But now we have a problem because this is not enough. We cannot explain our quantum gravity. We cannot unite. You have to put now we have to put the c-speed limit, the barrier, more above in order to explain. Because remember, I told you, the vacuum is not the background. It seems to be the background because it's hidden.
Okay, yeah, you
mentioned the top. Energy-wise, the top is here. Here is matter. Here is matter light. It's not the background. The vacuum is the top.
I think we got that.
Higher.
Okay, Emmanouil, we know that. Yeah. We understand the point you're making there, I think. Yeah, so I was just going to ask a quick question about the mass of gravity, because you calculated a mass that was very, very small. And I'm just wondering, what implications does that have in a wider framework? Is it a theory of massive gravity, or is it just that's too negligible to even consider?
Yeah. There's actually a researcher, it's called, I sent you the name. Whenever you introduce gravity to a particle, then you
mean mass?
Reduce the mass. Yeah, when you introduce mass to a particle, a massive particle, then you shorten also the range of influence.
Sure.
So we know gravity is like electromagnetism, has an infinite range of action. So that's why actually they say that the gravity must be massless, because it cannot have any. Because we see that gravity is like electromagnetism, infinite. Instead, the weak force, it's called weak because it has a very small range. And why it has a very small range? Because the elemental, the particle which is responsible for the weak force, the Z boson and the W plus and minus, are massive bosons. Yeah, that's why that's actually the explanation. So now we come to this is a very correct answer. If my particle is massive in my model, then this contradicts the infinite range of gravity.
Right.
Okay. So, but I have to neglect this. This is just an effective description. Superluminal energy cannot create mass. The only mass created is the evaporation energy of the graviton in my model, which has this 10 minus 9 per cubic meter joules energy. And then you can, with equivalence principle, you can have a mass there. But the bare graviton, which is rotating superluminal, cannot create mass. This is just a calculation, just an indication. If we hypothesize that this graviton comes from the dark sector to our luxon spacetime, what will be an effective mass? But I actually have a note below my presentation. Sorry. Are we sure? Present.
Sure. If you just read the note off, even if you have it there.
Yeah. So here, can you see the screen? My screen?
Yeah.
Yes.
Yeah. So here is similar to that. Superluminal vibration of the graviton cannot be observed in the lab frame because it is higher than the Planck frequency limit of our luxon spacetime. So here is the limit according to the fastest propagation of information of the photons, which is at c speed. This is the allowed maximum frequency we are allowed to see on the universe. according to quantum field theory, but also general relativity. Above this theory, we cannot, because it's less than 1 Planck length now. So that's the maximum frequency we can see, we are allowed to talk about. Yeah, but the graviton, because it's it has a very sub-Planckian, the Berg graviton, it has a much higher frequency of this, and we cannot see this frequency. But what is frequency? Is the oscillation inside the Higgs field. So the electron oscillates, and we see the oscillator perceive this oscillation inside the Higgs, because the theory is that the electron banks against the Higgs field, the Higgs boson, the banks, the collide all the time. Every time it collides, it reverses its oscillation, something like that. It bounces, you know. And this oscillation we perceive like mass. But now we are in the realm of beyond the photons, space-time. So the superluminal energy cannot produce any mass. It's not possible. So forget that. It's just an effective calculation here.
Okay.
Just don't take this in face value. Yeah. This is if the graviton will be introduced in our photon spacetime, what mass it will have. Just to show you here, this is just to show here that because the superluminal energy produce very small mass. It's very easy to identify. If here is the Einstein equation, yeah. If you have here an enormous mass, a very large mass, you will think, okay, now we will produce also a very high mass, right? Because you have yes, but if you have an enormous speed of propagation of energy, superluminal, this is in the denominator. And then even if you have a very large mass, a very large energy, it produces a very small mass. That's all about what I'm saying, just to emphasize the fact that superluminal energy cannot produce any mass. Mass is just an exclusive phenomenon for subluminal and subluminal energies. When you enter the realm of superluminal energy, which is a total different phase of energy, you don't have the concept of mass. There's not only energy, and this is also indicated by this here. Okay.
Emmanouil. Okay. Very interesting. Thank you,
Emmanouil. When keep your reasoning. Give me just a minute, please, to not lose the point. From an iSpace theoretical point of view, there is one thing completely speaking for your theory, and one thing possibly completely speaking against it, if you don't find a compatible.
Sorry, guys, can you hear me?
I think Emery is coming.
Yeah.
Can you hear me?
Yeah, I can hear you. I can hear you.
For a moment, I forgot it. I forgot that I dropped out from the menu.
So what I wanted to say is there's one thing from iSpace theory which is completely clear that speaks for you. And you said that gravitons are chargeless, and in iSpace theory, charge is golden ratio, identified as root cause of mathematical charge in iSpace theory is golden ratio ampere or iSpace ampere. Interestingly, the same, and this is not negotiable. It is proven. Consider that as 100% fact for the moment, even if it's not in the physics books yet. But
yes, Christian. But now we're talking about
quantum of gravitation from iSpace point of view as a force. You see, it's 3 over c to the power of 4. In a sense, 3 to the power 299792458 times 1000 to the power of 4, which is no geometry. There's no pi. There is no golden ratio. Hence, we have only iSpace integer geometry of pi like 3. The 2 times pi 3 times 1 is a voltage quantum of iSpace IQ unit system, and it all speaks exactly in front to the front of why your model could be likely the correct one. But there is a problem with it from the frequencies point of view, because we have a cutoff frequency in iSpace for the electron. And this is also a die-hard, non-proven yet experimentally, but we see when quantum core clocks come up with 1,000 times precise more higher range, we are exactly in the domain of iSpace theory, and iSpace theory predict breakdown of clock itself is a quantum of time. And quantum of time means you have multiples of 1 over 6961 iSpace seconds. And only that, there is nothing other allowed by iSpace theory. You will not get higher frequencies. And when you have the normal Planck equation, which is as nice as it is, with Haber C over to the power of G, C of 5, and you get Planck time, and you multiplied it for reasons for surely from your model 1 over 2 pi or something, that doesn't change the frequency high. Then you need to understand in what medium or from what non-charge-based entity can create frequencies like that. I'm not saying that it's not possible, but I guarantee you over time it's not possible with an electron.
Yes, I disagree with that about the electron, but the speed of propagation of inside a medium, and I believe that the vacuum is actually a medium, depends from the energy content of this medium. So in our space-time, the propagator of information are the photons, but it's not. It could be actually possible that there's another propagation of information.
You have to be very careful with the linear extrapolation from Planck unit arguments. Many people do that, and I think they're all wrong, and possibly including you.
No, I'm saying
you cannot just take Planck arguments and make them into a space-time argument, because the Planck arguments are, from my point of view, purely mathematical. Nobody told ever if they get ever physical in that range.
You're roboting a bit there, Christian. Could you repeat that?
Oh, okay.
I didn't hear Emmanouil.
Oh, okay.
Better. Emmanouil, can you repeat what you said? You were on mute.
Go ahead, Emmanouil.
Yes, I don't disagree. I don't disagree with that. Can you hear me? Can you hear me?
Yes.
I can hear you now.
I don't disagree with your point of view, but remember now that the propagation of information is not propagated in the dark sector by photons. So this applies only for our luxon spacetime. I'm saying that the propagation speed inside a medium depends from the energy contained of the medium. So in our spacetime, we have luxons. The propagator of information are the luxons. But what I'm saying is that there's another propagation of information, of energy, which is the dark energy. So the dark energy could have a much faster speed of propagation than the information propagated by luxons, by photons. That's all I'm saying. So, yeah. But I don't agree. I don't disagree with your. Yeah, of course, about the electron. There's a cutoff in the electron.
Nobody knows in general, in all theories, including string theory, if Planck time arguments, Planck length arguments are physical or just a mathematical Hirngespinst.
Yeah, but all the restrictions, Christopher, all the restrictions, if you very deep inside the mathematics, the formulas of the physics formula, all the restrictions emerge because the speed limit C. If you say that the limit is higher, then you make the calculations again.
Yeah, it's not that easy because you're saying two things, Emmanouil. You say that the speed is near infinite higher in outside the luxons range, but that doesn't change the rules in the luxons range, not at all. So there are ice. Discussing about ice is not the same than discussing about water.
It's not discrete. Yeah, it's phase transition. Yeah, I don't mix
it. It's a different thing.
Yeah. The only connection link is the 0-point energy. That connects the two spacetimes. The only what concerns electromagnetic force, the weak force and the strong force, because they are made, according to my theory, with the same vacuum flux energy. The only thing that connects the dark energy sector, the superluminal, with our spacetime sector, the luxon spacetime, which is Lorentz invariant, is the 0-point vacuum energy. It's the tip of the iceberg we see. But gravity is commuted directly from the dark space sector to a luxon spacetime sector, because it's not energy; it's just the absence. So they can be transferred directly. So the origin of gravity is of quantum gravity is the vacuum. It's not matter. It's vacuum space. Yeah. Yeah.
We had Emery there for a second.
Yeah, Emery.
Yeah.
That was a bit unfortunate because, it seemed kind of like I've forgotten the word, but serendipitous, because there you were talking about some sort of discontinuum between the the superluminal realm and the luminal realm, and Emery was there briefly. I was going to bring it up, but Yes. Do you think that there's a connection there then, Rajan and Emmanouil, between the theory that you're proposing here and the other one that Rajan and Emily is working on?
Yeah. So one of the things I want before go on, one of the things about Christian thing is that there's something called Zeeman splitting factor. So we have the electric and the magnetic field forming. So suppose everything is magnetic because of the monopole thing like that. But with a rotation of the magnetic field, you start creating the electric field. And the Zeeman splitting says that it will split, like Emmanouil has shown all the 4 figures into the magnetic thing has north and south poles. So you have the symmetry, gauge symmetry says that you have to have the opposite one to balance it. And then you have the chirality that he's bringing about, the left-handed and the right-handed. So you have all the splitting possible from Zeeman splitting factor of the electric and magnetic fields, which is connected to the Maxwell equation. So I think they all fall back into that. So if it's locally it's distorted or perturbed, that's the only question. How it's locally. So we need a very high-level math to prove that highly random situations and create a local distortion or a perturbation, create that. So that's the only proof need. So I have given about longitudinal waves. Longitudinal waves keeps going. It can curl around and create a vortex because of the. So I believe that gravity is not a force. Gravity is a gradient. Many people are questioning. Like there was a couple of people, and that's a very good. The old physicist, retired physicist, I forgot her name, but she said that the whole quantum gravity will be wrong because of the gravity is not a force. Now I agree with that. Yeah. So I am not considering that. If you consider gravity is not a force,
it appears like a force, but it's not.
Yeah, it's not a force.
It's again, my saying is that the gravity is the absence of any force. But because then you have all these pressures from the dark energy and the 0-point energy that creates a negative pressure. So
quantizes that force to a quantum. So for the absence of a force, it's highly quantized, and ice-space theory tells you, if you want it or not, that the square of the alpha G constant, which is electron mass over Planck mass, or electron you can also calculate it as a force ratio, but when you take it with the masses, you get it at alpha G. And when you square alpha G and multiply with the Planck force, you get the quantum of gravitational force of ice-space. And I don't think this is random. Now, when you say that this is an absence of something which gives a negative pressure, that is still fully compatible to what ice-space theory says, but you have to find a way to quantize that absence.
I can quantize it right now. I show you how the quantization is. I have to again to present. Sorry.
Look, there is no cold, because cold is not existing. Cold is the absence of heat. Okay, that's simple. And with the same argument is what you tried to tell us, and I think I can agree to that. Is that there is no gravity. Gravity is the absence of negative pressure. This is just a model thing. What you have in your brain is not also mathematically induced. It's really a cool view that inside your rings of the gravitons there's nothing, and that nothing creates negative pressure. So that I like that from the model point of view, because then everything else makes it automatic.
Okay, I show you now the quantization.
How is that quantized per ring then, or what? You need the quantum.
I show you the quantization. So the ring is 2D. Okay, 2D for practically. I mean, nothing is 2D, but it has no thickness. Let's say, just to simplify the model. Yeah.
Okay.
So the quantization of gravity is the surface here. The surface here is the quantization of the area of the hyperspace of the void.
That is constant per ring, whatever the ring number of rings.
Yes, it's constant for every graviton.
This is absolutely accepted. This is compatible to ice-space.
And if you want to do it differentially, you have to then calculate this surface area and make the ratio with this surface area. But you have to include also the the thickness here of the dark energy ring, and also the 0-point energy.
Do I understand properly that the ring size is strictly quantized and aside of ring vibrations is strictly constant in your model?
Yeah, the radius is constant. Yeah, it doesn't change. The only time it changes with cosmological time, because it slows every so lightly. It starts and after 2030 years power of 10, it will drop down to c speed. But this means also that it will at large. It will come larger in size. Every time it drops down in speed, it will come larger and larger and larger, and then will come to the photon realm, the speed of light of C, and it will actually have much larger dimension. So, but when now at the current the speed, independent of interaction, it doesn't deform. You cannot deform this. This is superluminal energy. This is an unbreakable ring. From externally, you cannot disrupt this.
Thank you very much. I have to unfortunately leave. I see
excuse me. Excuse me. You want to introduce Emery here, Emery Taylor, who works with the US team. Yeah. So yeah, Emery, this is our group. Yeah.
So can you introduce me to the gentleman? Someone to introduce me to the.
Emery, we have met last time. I unfortunately have to leave. I'm in 3 hours now, but it's not because I'm tired. I have to really leave at 9 p.m.
Thank you again, Christopher.
I have to look at the rest of the video when I have time to.
Christopher, thank you very much.
Thanks, Christian. That was really interesting. Great question.
Yeah, thank you.
Thank you very much, Christopher. Your questions are always to the point.
Nice to see you. We'll see you next week. Hopefully.
Very high-level discussion there that I was.
So Emmanouil, So Emery, started. I described one of the. I think when Christian was there, but I will repeat some of the things. I don't want to go into because Emery is going to describe more. I'll give you like 1 or 2 minutes about Emery. How Emery came to be to me is that through. He was looking for a lot of people. He has interacted with a lot of particle physicists and other type of physicists, quantum physicists, and even general relativity. All those people. He has attended a lot of the high-level, real physicists, so to say. We are upcoming physicists, but the already established physicists. So he has interacted with them. So he had an original idea about discontinuum energy because he thinks that at the level, you have different types of reality. So that is his main idea, that we see that way, but there is a physical reality, a mathematical reality, 5 types of realities. He will describe that.
I completely agree. Yeah. Nice to meet you, Emery. Nice to meet you. Can you hear me?
Emery? Yeah. Emmanouil is talking. Yeah.
Can you hear me? Yeah? I'm muted. Can you hear me? Hello? Yes, Rajan, can you hear me?
Yes,
yeah,
I can hear you.
Okay. So nice to meet you, Emery. Nice to meet you.
Emery, your sound is very low. We can't really hear you. That's a bit better, maybe. Can you guys hear him? I can't really hear him.
Not yet. Emery, can you adjust your volume? No, I can't. Oh, you have internet problem? Also.
Okay, Emery's just here as an observer then, and I'm that's fair. But yes, good to see you anyway.
Yeah, last time he could talk very well. He presented, and we too had a great discussion last week. But I think he has a problem with his system. I think.
He's using his cell phone. He's using his.
He was using cell phone initially. Then he went to computer, but somehow it worked last time. But I think he has a problem still. So we will see.
Okay, guys. So what you want now to do? Do you have questions? Should we break or?
Yeah. Yeah, there are a couple of more questions. Okay. So I think that your vacuum polarization is closely connected with Zeeman splitting constant. That's one thing.
That's very interesting. Yeah. Can you send me the paper? Can you send me the paper?
Yeah, I'd like to see that as well.
Yeah, I mean, there is no definite paper. There are many references, like for screen. Yeah. So we have to go to Wikipedia and pull out the references. So I can do that.
That's also the Helmholtz decomposition thing, is it?
Well, it's not directly connected, but it will eventually connect to that. But yeah, you are saying, yeah, it has a subtle connection to Helmholtz decomposition. Because I think Helmholtz decomposition is much more general. It's like the Noether. For me, it's almost like the Noether theorem of symmetry. You know, Helmholtz decomposition. Yeah, it's much higher level. And
one thing that sorry to interrupt. Sorry, Rajan. One thing that the whole Emmanouil's talk reminded me about is the work that I'm currently doing with the. Remember, I did the leptogenesis talk 2 weeks ago, 3 weeks ago, and then so I've run into some problems with that, but then I fixed them, and currently I'm working on a simulation that basically a leptogenesis simulator. So the particles interact, and then they create photons and electrons and so on. But it's done in like a haphazard manner, you know, the particles just zip around, and then if they bump into each other, a reaction occurs or doesn't occur, as the case may be. So that's kind of like a, you know, noisy environment. But within that, then, if we look at the structure of the particles, they have a symmetry which corresponds to maybe a subgroup of SL2Z. So so that's how the rules are made within the foam, if you like, of the structure. But the interesting thing is that you have these 6 particles roughly that are anti each other. So a bit like the red, green, and blue quark color and anti-colors, you know. So it's kind of linked then with SU2 quantum chromodynamics, SU3, sorry. And so that's interesting. So we have SU2 and we have SU3 because of the SL2Z part that I was talking about. So then when when some of these combine, they combine to create 2 other particles that I've called tri-Wen particles. There's the tri-Wen and the anti-tri-Wen. And they are like...
sorry, what's the name again? Tri-Wen.
Because remember we were trying to think of a name, and I was just calling them the X particle, but that already exists. So then there was the King-Wen sequence of the I Ching, and so basically I just called it the Wen particle. But there's 6 particles of the Wens, so they could be hexawen, like hexagram, and then there's this other particle that has a charge of 3, so that could be a tri-Wen, like a trigram from the I Ching. So, but when they combine in this model to create an electron, which has twice the charge, because, you know, 2 charges that are 3 come together to make 6. So it's pretty rudimentary, that part of it. But I don't know that. So, but what I'm wondering is, if you have an electron, and then could you decompose it, like either, I was thinking through the Helmholtz thing, but possibly through the Zeeman thing. We take it apart. But the magnetic part of that isn't going to have a charge, is it? It's just the gradient part will have the charge. The other part doesn't have any charge. So we can 3 + 3 = 6. That worries me a bit.
Very interesting. So I think it's like a superposition in a way, you know, like the electric and magnetic field come together. So you can do the opposite of decomposing it, and you pull out the electric and magnetic part, then they because it's all in the rotation, right? And then you can make them rotate, because you have half spin particle, right? It spins there and then it connects there. So you get the symmetry.
2 magnetic monopoles. You can get it from 2 magnetic monopoles and join it together.
But in the boson, you have the whole spin one, which is a pi to rotation, right? Then you have the graviton, which requires 2 pi rotation, right? That's how we get spin 1. So it's in the rotation. So it catches up in the rotation. So it's rotating, it catches up. It doesn't allow it to rotate. So it has to go like that, oscillate, like electric and magnetic field. But if it's pull out, then it can start rotating and eventually create a graviton that Emmanouil is talking about. Everything is pulled out, so that graviton eventually is able to rotate in the 2 pi formation to create the spin 2.
Yeah,
I think it's a pi
I don't have another picture. I show you in my model, not of the graviton, but the first purpose of the electron. I said that in the beginning, during the Big Bang, I don't know what the beginning was. There were magnetic monopoles, and you have, the Dirac monopole. You have a monopole which is a north magnetic entity, which has only north magnetic pole, and then you have the south, the anti-monopole, which is vortexing, say vortex here and the vortex here. And Dirac says there are actually no magnetic monopoles, but there's a Dirac string there, which join. These two magnetic monopoles can be far away, relative, 1 meter, 2 meter, could be also 1 kilometer. I don't know what, but they always join with this flux tube of which is described as also Dirac string. So now, what I'm saying, what my hypothesis is that the Big Bang, there were initially magnetic monopoles, and then they came together because, in my theory, the electron is a dipole vortex.
Yeah.
Yeah. So then, now because the string now here, but then they came together and formed the dipole vortex, and this is actually here shown in my, the toy model I have for the electron.
Of course, yeah.
This is here.
As everything cools and the energy gets less, they come together.
Because they have different rotation. If you see two vortices on C, and they have the two vortices on the surface, you have a clockwise rotation. So if they come together, they join. It's called modon. They join.
Modon.
They form the two vortices on the surface.
But then that's a problem if you have this non-deformable graviton. How is it supposed to break apart to that degree where it can create two monopoles? Maybe these are two slightly separate theories, or maybe
vacuum polarization. Vacuum polarization.
Imagine in my model, the graviton is like the Lego, which makes up every particle. These particles are not elementary. They're telling there about the standard model. I don't believe they are elementary. They are made off from some kind of energy, and I believe it's the graviton that makes up all the particles of the elementary particles.
I know that.
The vacuum flux,
you believe that the graviton can be deformed to that degree? Well, I suppose it's being deformed anyway inside the
No, the graviton is not deformed. It's just a ring. So if you, Christopher, you have a ring, yeah? You have another ring. You join them. You continue joining these two rings. Then you have a tube. You glue together the two rings.
Like small rings.
Join.
You have a tube.
Tubular.
I see. So the ring around the electron is made up of little
Maxwell.
Tubules. That's interesting. Yeah, I like that.
I thought that was very clear.
I know I missed that point. Sorry, I totally missed that point. I didn't understand.
So let me show you.
Didn't make the connection. So does that also give some sort of to the electron then, because you have these two different rotations?
Yeah.
Interesting. That's a good idea.
So, Emmanouil, it's like a smoke ring in a way.
Yeah, this is a very good theory. I like this. This is very. There's a lot going on.
Look, here is my. Can you see this? The animation. Can you see that? Yeah. So this is the toy model for the electron. The electron is a dipole vortex. Yeah, and you have the charge flux here. So each of the lines here, of course, they're not lines. They're just this moving surface of this flux, of this vacuum flux, and this is the lines are just to show the direction of flow of the. Imagine like water, like a spring. We can see the direction of flow. So each of these lines here, each point of each line is just a ring, a graviton.
Okay.
Yeah?
Right.
So
yeah, now I get it. Yeah, now I'm understanding.
yeah.
That's very good.
Now,
I
I thought it was obvious. So now look here, look. So here you have the ring, yeah. You have the ring here. You can see that. So imagine now. Let's go here to just a flux line of a magnetic field. Sorry. Here. So here, imagine this is you have a magnet and you have just a single flux line of the field on the air. So now each point you have here the gravitons, which is a ring, a 2D manifold, and then you put them, you stack them together here in a line. You align them, and this makes a tube. So that's all. That's all what I'm saying.
Does anyone?
So now you have the connection of electromagnetism with gravity.
I understand now. I just wonder, you know what this reminds me of a lot, and I'm sure Rajan will know.
Maxwell. Maxwell.
No. Wait a second. Give us a second. The Hodge part. You know the disc. The Hodge. What's it called? Part of the. John Hodge's work with the disc.
The Stoy model. Stoy model.
The
Hod. Yeah. So but there's definitely a big, what would you call it?
Parallelism.
There's a lot of similarities there between the two models, but one was for the photon, was it? Or
yeah, he did that for all of them.
John used the magnetic dipoles to form any particles. So you use dipole, magnetic moments to form any particle of the standard model table. That's what John did. I do different things. I just describe the vacuum flux.
Different. Yeah, there's definitely connections there. That's really
cool. I say that everything, all the particles of the standard model, which are not elementary, again, according to my theory, are composites, and they are made from vacuum flux. Imagine like a vapor, a smoke ring. A smoke ring. So each manifold is and so but the elementary particle of the vacuum is the stable graviton, and it is a ring of superluminal energy, but it evaporates to a mantle around it, which is it's vacuum flux. So this 0-point energy vacuum flux is from which every particle of the standard model is made. The electron, the quark, whatever, the W bosons, the Z bosons. That's my assent.
Yes. Okay. Yeah. Very interesting. I like it seems like everything is coming together there. Everyone has, like Rajan said at the start of this, everyone has a different part of the puzzle, but it's just like how to put it all in place.
As I explained before, if you want to make a theory of everything, you need one particle that consists all other particles. That's the meaning of the theory of everything. You cannot have a variety of particles. There must be only one particle, an elementary particle by which everything consists. That's the theory of everything. For me, you cannot have theory of everything if you have more than one particle. Yeah.
Okay, but then what created the particle, or because that's the difficulty I have with the thing that I came up with. So it's like leptogenesis, but there's these three particles.
But your theory is possible to be correct, but it's 10 levels above me. I'm very low. I'm just describing the fabric of space-time itself. It has nothing to do with.
I see what you mean. Yeah, it would have to be like.
You can have any manifold. You can have any manifold of coherent formations of gravitons.
Yeah.
And then you can have any particle. Yeah, of course.
Yeah, no, that's really interesting. Well, one thing that I did notice about the odd thing about these particles that I'm suggesting that came from the I Ching or the I Ching is that there's, like I said, there's 8 of them, and there was in the bosonic sector of the whole 600 cell, 24 cell, and 120 cell theory. So each of those is like grand unified field theory. And then a theory of everything that includes gravity, so like five different theories of gravity, because you need 5 for the 5 different.
I'm sorry, but with any respect, but I disagree. If you want a theory of everything, you must conclude to one particle.
No. This is totally different. This is a theory of everything in the standard model sense, where we need.
Okay.
Yeah. So we need all these groups, and then we have to combine them, and you get 5. But then those all, which is also interesting because it's the same number of string theory models, but it doesn't really matter. So they all.
Really? Oh, that's interesting.
Yeah. So see, but then they all collapse in like brane theory into one, and this happens the same thing. You have the.
So how many particles you find in total? How many particles you find in total? How many particles?
Well, in the original 24 cell model that everything grows out of, there's 48, and that's 24 fermions and 24 bosons.
Okay.
So in the boson model, there's a space for 8 particles left. That aren't, well, actually 9 because of the central one, which is the graviton.
And you say that string theory makes the same prediction because now the accepted theory of string theory is 11 dimensions. You have to combine 11 dimensions so you get your 48 particles.
Well, no. In my model, the 24 cell, which is used in connection with bosonic string theory with 24 dimensions. But the 24 cell is a 4-dimensional object, but it has obviously 24 vertices and 24 lines, I think, or it's self-dual anyway. So that just means it can transform into itself. It is a group. And so then if we take 5 copies of that, we can create the 600 cell. If we take 5 copies of the 600 cell, and the 600 cell just has like more. We can include more particles like the color charges and spin up, spin down. Actually, we have a lot of that stuff anyway. So and then we take 5 copies of those, and then you can collapse it down. So the point I'm trying to get to there, as eluded me. Sorry, I forgot what I was going to say.
No, I believe that you're trying to construct a model that will explain geometrically every formation we can find in nature of particles, right?
Yes, that's right.
So some kind of framework, geometric framework from which you can extrapolate every particle from these geometries.
But it also, so since there's the 600 cell is the dual of the 120 cell, that means the 120 cells of the 120 cell will have a particle at its center, and it will be surrounded by other particles. But so we could do things like we have a lattice then, so we can do all of the usual stuff with that in terms of, Lagrangians and trying to get the masses and stuff. So
Christopher, be careful. If it's a fermion, you cannot have nested one particle inside the particle because the Fermi exclusion principle. If it's a boson, it's okay. If it's a boson, it's okay. But
and maybe misunderstood. The cell is like an empty void within the. So it's just got the particles are around it, and then the dual of that will mean that if you take the average of all those positions, you get the center. But obviously, it would be a waveform because it wouldn't be like at a specific point or anything. So that's pretty cool. But so I think so there's 8 particles missing in the bosonic sector of the 24 cell according to my model, and those can be filled by these when particles that I've just spoken about. But previously we said, okay, so there's this leptogenesis, and these particles are create the fermions.
But leptogenesis is only direct the Big Bang, I believe. Leptogenesis is only direct the Big Bang, not at current time, right? Leptogenesis refers only to the Big Bang.
Yeah, I don't think. Yeah, I'd agree. So it's early on, but this is the concept. There's these.
So it's a Big Bang theory. The theory is also a Big Bang theory.
Well. Yeah, no, it's just because in my total model with the anamorphic universe model, the hypersphere and the tangent space. Well, the tangent space is always there, kind of. But the hypersphere, when it gets going, could have expanded and there was nothing in it, and then the matter was added in afterwards, like we saw with that diffusion of matter that comes out. So leptogenesis could have happened after the universe was created and after like any kind of expansion. That's basically what I'm thinking. So
that's actually the conventional view, that the leptogenesis happened after the initial inflation, after the inflation, and after leptogenesis
this inflation would be it would be absolutely minuscule compared to like Alan Guth's proposed inflation, which was just, you know, mind-bogglingly huge. This is only in the height on the hypersphere level. Yeah, and then the matter gets added in afterwards, let's say, or generated, and through this process. But so the process that because these new particles are in the boson sector of the 24 cell, it must mean that they are bosons, but they are very strange bosons if that's the case, because they have charge. That's okay. They also have chirality, but it's like a broken chirality, which, and I don't.
What you mean broken?
To have chirality, so it's an interesting little thing. That's why I initially thought they were fermions.
So
I'm questioning that.
What you mean broken chirality? What you mean broken chirality?
Well, it's broken because there's 6 of them. There's 6 particles, but 4 of them are left-handed particles and 2 of them are right-handed particles.
Ah, okay. But why you wanted them all the same chirality? You wanted them all to have the same.
Oh well, at least if it was even, like 3 and 3. Yeah. But 2 and 4.
Okay. So it's asymmetric. Yeah, it's not
asymmetric. That's what I mean. Yeah.
Asymmetric. Interesting.
It could be imaginary. You know, the other things may be imaginary. So you don't
maybe Emmanouil wants to speak. Emmanouil wants to participate to the.
Are you able to?
To speak. If you want to speak. Yeah.
No, I can't get no problem. Okay, we can barely hear you. Will you be able to do your talk?
Just microphone here. There.
You'll be able to fix your technical issues, I hope, Emery, for your presentation next month. Well, no pressure, like. But yeah, I'm looking forward to that. There's going to be a very
microphone here in the earpiece, a microphone that goes close to the mouth. You don't have this? The microphone.
No, neither do I.
He has a problem with a cell phone and adjustment. He's trying to get it from cell phone to the computer, something like that.
I'm on a cell phone like this because the internet in the apartment is not working.
Something around an apartment.
Yeah, the sound is not coming through. Also,
I think we did 3.5 hours. That was really interesting, Emmanouil.
Yeah, I mean, we had one question about the coding.
You are always pleasure. You are my pleasure to speak with you.
Great.
Yeah, thank you, Emmanouil. We hope to see you more often. Yeah.
Okay. Bye.
See you.
Thank you.
Thanks, Emery. So you had a question about coding, but we will get to another time.
So,
if you want to get through the emails, or I'll end.
Briefly, like 5-10 minutes.
Sure.
And then we can do email. But 2 things. One of them is the Python itself. See, the problem, I'll show you the problem that we are facing, and then I can send the thing, because will
I close the stream now? Like, sorry, end the live stream.
Yeah, you can. If you want to.
Good one.